Yo, let's learn about the AI actually hey. Oh, let's put this one in put this one yeah then actually it equals to open animation.
Hey there, how's it going, everybody? In this series of videos, we're going to be learning how to use the matplotlib library in Python. So matplotlib is a plotting library for Python that allows us to create some great looking graphs from our data. So this is used a ton in the data science field and also in applications where we need to visualize our data. So I have the matplotlib website open here, and we can see on their example page that you can make some really nice visualizations using matplotlib. And we'll be learning how to do several of these in this series. So in this video, we're going to be going over the basics of matplotlib and start out with an easy line plot. We'll also learn how to customize the plot style and labels to the axes, add a title, create a legend, and things like that. Hey there, how's it going, everybody? In this video, we're going to continue learning about matplotlib and seeing how to create some different types of charts. Specifically, we're going to be looking at bar charts in this video. We're also going to see how to load in data from a CSV instead of just having our data directly within our Python script, because most likely when you're plotting data, the data is going to be coming from another source like a CSV file. Now, I would like to mention hey there, how's it going, everybody? In this video, we're going to continue learning about matplotlib and seeing how to create some different types of charts. Specifically, we're going to be looking at bar charts in this video. We're also going to see how to load in data from a CSV instead of just having our data directly within our Python script, because most likely when you're plotting data, the data is going to be coming from another source like a CSV file. Now, I would like to mention that we do have a sponsor for this series of videos, and that is Brilliant.org. So I really want to thank Brilliant for sponsoring the series, and it would be great if you all could check them out using the link in the description section below and support the sponsors. And I'll talk more about their services in just a bit. So with that said, let's go ahead and get started. Okay, so in the last video, we learned the basics of Matplotlib and how to plot some data and customize our plots in different ways. I have a stripped down version of the code that we wrote in that video open up here in my editor. And I'll have a link to this code in the description section below if you'd like to follow along. But just in case you're not continuing from a previous video, let me go over this code really quick. So first, we are importing plot up here at the top, pyplot from Matplotlib. We are using a 538 style for our plots. Our ages here, this is our x-axis. It's just a list of numbers. Dev y, this is the values that are going to be on our y-axis. And here we are plotting out that data. So we're plotting out our x values, which are the ages, the y values, which is our dev y here. We're giving it a custom color and a label. And I've got some commented out code right here. All of this data is median salaries for different ages. So this is for developers in general. This is for Python developers here. This is for JavaScript developers here. But I've got those commented out for now. We are also putting a legend on our plot, giving it a title, X and Y label, giving it a tight layout, which just helps with the padding. And then lastly, we are showing it. So when we plotted our data in the last video, we used this plt.plot method. And when you use the plot method, it will use a line plot by default. So if we run this, then we'll see something kind of similar to what we saw at the end of the last video. So we can see that we get a line plot here for the median salary of developers. And again, this is some data that I took from the annual Stack Overflow developer survey. But let's say that we wanted to show this as a bar chart instead. Well, to do that, we can simply use the bar method instead of the plot method. So if I just change this to use bar instead of plot, then we'll have a bar method, or a bar plot, sorry. And just like that plot method, we can pass in our x values first for our x values and the y values for our y-axis. And additional parameters here can be passed in as well, like color and label. So I'm just going to leave that as is, just like it was with the plot method. And if I run this, then we can see that now this is plotting our data and it's represented as a bar chart instead. Okay, so that is plotting the data for all developers who answered the survey. So like I said, I also have the data for Python and JavaScript developers as well. And right now those are commented out. So what if I wanted to include those in our bar chart? Well, first of all, you can mix and match some plots. So if for some reason you wanted the Python and JavaScript data to remain as line plots and just overlay that onto our showing it. So when we plotted our data in the last video, we used this plt.plot method. And when you use the plot method, it will use a line plot by default. So if we run this, then we'll see something kind of similar to what we saw at the end of the last video. So we can see that we get a line plot here for the median salary of developers. And again, this is some data that I took from the annual Stack Overflow developer survey. But let's say that we wanted to show this as a bar chart instead. Well, to do that, we can simply use the bar method instead of the plot method. So if I just change this to use bar instead of plot, then we'll have a bar method, or a bar plot, sorry. And just like that plot method, we can pass in our x values first for our x values and the y values for our y-axis. And additional parameters here can be passed in as well, like color and label. So I'm just going to leave that as is, just like it was with the plot method. And if I run this, then we can see that now this is plotting our data and it's represented as a bar chart instead. Okay, so that is plotting the data for all developers who answered the survey. So like I said, I also have the data for Python and JavaScript developers as well. And right now those are commented out. So what if I wanted to include those in our bar chart? Well, first of all, you can mix and match some plots. So if for some reason you wanted the Python and JavaScript data to remain as line plots and just overlay that onto our bar chart, then we could simply uncomment out our code here, and we could just run these as plots, and that will actually overlay line plots on top of our bar plot. Now, that doesn't make much sense in this situation, but depending on your data, you might find that useful. Okay, but what if we wanted to include these in our bar chart as bars side by side with the other data? So you might think that we could do this just like we did our line plots and just run those using the bar method as well. But that's actually going to give us some issues. So let's try that real quick and see what that does. So I'm going to change these to use bar, so plt.bar. So I'm going to run that. And we can see that this doesn't quite look right. We can't even see the data for all of the developers, and the data for Python and JavaScript is overlapping. So how can we put these side by side? Because right now they're just all stacked on top of each other. So we can do this by offsetting the x values each time we plot some data. Now, I actually think this is a lot harder than it should be. It seems a bit hacky in my opinion, but this is just how we have to do it. So to do this, we're going to have to import NumPy and use that to grab a range of values for our x-axis. Now, if you've never used NumPy before, then don't worry too much about it. It's just going to use one simple function. Now, I believe NumPy should be installed when you install matplotlib, so we should just be able to import it without doing any additional installs. So up here at the top, I'm going to say import NumPy, and I'm going to import that as MP. That's a convention there when using NumPy is to import it as MP. And now, below our x values here, where we have our ages x, I'm going to create a range from these values. So I'm going to say x underscore indexes, and I'm going to set this equal to mp.aRange, and I'm going to pass in the length of our ages x list here. And what that's going to do is it's going to create a variable called x indexes, and that is an array of values. And of our x values. So basically, it's a lot like having a list with an index starting at 0 and counting up numbered is it's going to, or use here where we have p. So NumPy should be installed when you install matplotlib. So we should just be able to import it without doing any additional installs. So up here at the top, I'm going to say import NumPy, and I'm going to import that as MP. That's a convention there when using NumPy is to import it as MP. And now, below our x values here, where we have our ages x, I'm going to create a range from these values. So I'm going to say x underscore indexes, and I'm going to set this equal to mp.aRange, and I'm going to pass in the length of our ages x list here. And what that's going to do is it's going to create a variable called x indexes, and that is an array of values. And those values are going to be a numbered version of our x values. So basically, it's a lot like having a list with an index starting at 0 and counting up to our last item, but instead it's a NumPy array. So once we have that, we're going to use that for our x values within our bar chart method. So I'm going to copy that, and instead of using our ages here, I'm instead going to use those x indexes. So I paste those x indexes into each of our bar methods here. So if I were to run this right now, then it would look very similar to what we had before, but now we're just using those indexes instead. But now that we're using these indexes, we can actually shift the location of these by adding or subtracting to our values here. So if we think about it, they're all stacked up on top of each other right now. So let's shift our first bar to the left and the second bar to the right. But how far do we actually want to shift these? Well, we want to shift them by the exact width of a bar. So to do this, it would be nice if we specify an exact width for our bars so that this is explicit. I believe that they have a default width of like 0.8 or something like that, but just to be sure, let's create our own width variable. So up here underneath x indexes, I'm going to create a width and set this equal to 0.25. And I think the default of 0.8 is going to be a little thick with 3 bars being side by side. So I think 0.25 would be good here. But you can experiment with these different widths if you'd like to get different looks depending on your data. So now that we have a width, let's subtract that width from our first plotted values, and we'll add that width to our last plotted values. And that should shift those bars to all be side by side. So with our first bar plot here, which is right here, we are going to say x indexes minus width. Then for our second bar chart, we're not going to do anything because that's going to be in the middle. And then for our last bar chart, we'll say plus width, since we want that to shift over to the right. And lastly, before we plot this, we're actually going to need to tell our plot that we want the width of the bars to be equal to the width variable that we just created. And we can do that just by passing in another variable here. So right before color on all these, I'm going to add a width. Oops, let me spell that right. Width equal to width. And I did that for all 3. Of these bar methods. With the width of the bars to be equal to the width variable that we just lastly, our last index is minus width. Then for our second bar chart, we're not going to do anything because that's going to be in the middle. And then for our last bar chart, we'll say plus width, since we want that to shift over to the right. And lastly, before we plot this, we're actually going to need to tell our plot that we want the width of the bars to be equal to the width variable that we just created. And we can do that just by passing in another variable here. So right before color on all these, I'm going to add a width. Oops, let me spell that right. Width equal to width. And I did that for all 3 of these bar methods. So width equals width, here, here, and there. So now that we've done that, if we run our code here, then now we can see, if I make this a little larger here, we can see that now our bar chart has these all lined up side by side instead of being stacked on top of each other like they were before. Now, if you have more or less bars that you need to fit side by side, then you'll have to adjust the offsets accordingly for the number of bars that you have. The way that I did this was with 3, but if you added another bar, then you need to do an offset with the width added twice and so on. Now, also, if we look at our x-axis down here, we can see that we no longer have the age ranges that we had before. It's using the indexes since that's what we needed to do our offset. So to fix this, let's go back to our code. So I'm going to shut that down. And down here towards the bottom, we're going to need to use an xticks label to change the labels. And down here towards the bottom, we're going to need to use an xticks label to change the labels. So right here above the title, I'm going to say plt.xticks. Whoops, let me spell that right. So within this xticks method, we need to pass in a couple of arguments. So I'm going to say ticks is equal to, and those ticks are equal to the x indexes. Now the labels for those ticks are going to be equal to our ages list here. So we are using those x indexes for the ticks, and the labels, which are all of our ages that we saw before in the last video, we're going to use that for our labels. So now, if I run that, then we can see that now our plot has that for our labels. So now, if I run that, then we can see that now our plot has our x-axis labeled correctly. Okay, so we've looked here at vertical bar charts and how to add multiple different bars to that plot. And in a minute, we're going to look at how to create horizontal bar charts. But first, I want to load in some data that's more appropriate for a horizontal chart. You usually want to use horizontal bar charts when you have a lot of data and it looks too crowded in a vertical plot. And the data that I want to load in is going to be from a CSV file. So far, we've only used data that has been directly in our Python script, but most of the time, you're going to be likely using data from external sources like a CSV file. And sometimes you're going to need to work with that data a little bit before it's actually ready to be graphed. So first, let me get rid of the data that we've been using so that we can make room for data that will load in from our CSV file. So I'm going to remove all the way from our PLT xticks there. I'm going to go up all the way to our ages and remove all of that data. And for now, I'm also going to comment out our plot titles and plot show and things like that. And now let me open the CSV file and show you what this looks like. So I have this open here in my current directory. And like I said, all of this is going to be available for download in the description section below if you want to follow along. So this is the CSV file that I'm going to be loading in here. So this is also data from that Stack Overflow developer survey, but I cleaned it up a little bit and only grabbed the data for the programming languages respondents said that they worked with. So we can see that the top line here tells us what information this is. So this first column here is the responder ID. So these are just IDs for each person who answered the survey. And the languages worked with, these are the languages that that specific person said they knew. So this first person here said that they knew HTML, CSS, Java, JavaScript, and Python. And we can see that these languages are all delineated by a semicolon here. So each line here has all these different languages, and using these, we can graph the most popular programming languages from that survey. So let me go back to my script here. And like I said, let's say that we wanted to create a bar chart of the most popular programming languages that people said that they work with. So first, let's grab the data from that CSV file. Now, there are multiple ways that we can load in a CSV file. We could use the CSV module from the standard library. We could use the read CSV method from pandas. We could also use the load txt method from NumPy. Now, first, let's use the CSV module from the standard library since most people are probably familiar with that. But then I'm also going to show you a faster way using pandas and that read CSV method. So first, let's use the standard library to do this. So at the top here, I'm going to import CSV. And now I'm going to read that file using the CSV module. Now, if you don't know how to work with CSV files using the CSV module from the standard library, then I do have a detailed video specifically on that. So I'll be sure to leave a link to that video in the description section below if anyone is interested. Okay, so the way that we can read this in is I can say with open, and we want to open, that file was called data.csv, and it's in the same directory as this script, so I don't have to specify a full path. And now we can just say as CSV file. And now we can use this CSV module to read this in. So I'm going to say CSV reader is equal to, and I'm going to use the dictionary where we can dict CSV reader variable, and we just index, and I find that pretty helpful. So to do that, that is, okay, so over row, that out. Order to that row. So to clean this up, we access that key, you're actually able to plot the data that you want. So that's why I'm showing that process here. So in our case, we want to plot the most popular programming languages from the results of this survey. So we need to keep a count of each language that each respondent said that they work with. So there are a lot of different ways that we could do this as well. And I put out a quick example of how counters actually work. So let me open up my terminal here, and I'm going to run Python. And let me show you how counters work here really quick. So to import these, I'm going to say from collections, import counter. They are from the collections module. And now that we have a counter, I'm going to say C is equal to counter. And I'm going to pass in a list here. So I'm going to pass in a list of Python, and I'll also pass in of Python and JavaScript, those two values in my list. So if I look at that counter, we can see that this says, okay, I have a counter here. I have a key of Python, and that's currently set to 1. I have a key of JavaScript, and that's currently set to 1. So it's keeping count of how often it sees these values. So to update this counter, I can simply say c.update. And now I'm going to pass in a new list. So this new list, let's say this time I say C++, and Python. Okay, so now let me look at this counter. So now when we look at the counter, we can see, okay, now Python is 2 because it's seen Python twice. We saw it up here when we first created the counter, and we saw it right here when we updated the counter. It's still only seen JavaScript one time, the first time we created it, and it's only seen C++ one time. So now let's do an update one more time. So if I run that update statement again with C++ and Python, and then look at our counter again, now it's saying, okay, I've seen Python 3 times, C++ twice, JavaScript once. So this is what we're going to use to keep track of these at the top of my script data. So right above, and set that equal to an empty counter. So right now we only have the data for a single row, but we want to grab the exact same list of languages from every row. So in order to do this, we can copy what we've already printed out here. This big long thing here is what got us that list of languages from that single row. So let's copy that. And now we can loop over all of the rows of our CSV data and update our counter with the data and this will loop over that list of language next, like so above we've got some good data here. Okay, so since this script with 5 total here, well, to do this for us. So whenever I'm printing this out, I could say print when that is a tuple. So how list? So to do this, above this line be for the tuples that we got back from this most common method. So I'll say for, go to the next line here, and the language index, pin the second item to our print top. Now we can actually use these two lists for our plot. Now there's actually a way of doing this whole section right here. There's actually a way of doing that with a one-liner using the zip function and unpack. So I just there, and I'm going to plot the link, and let's check the most popular. Just say I save the items, read each method to use a horizontal bar chart instead, as they are, because our programming languages, actually now that I think about it, programming languages are actually the descriptive that we have together like a vertical bar chart here. Let me open this back up. Okay, so now let me run this. It'll be overly descriptive. So I'm going to get rid of that. Languages, that's pretty self-evident. Okay, now at the top with this or anything like that, it's actually going top, and I think that looks in place. It really reverses those in place, so we don't that bar 8 set. Now we can see that we have then we'll need and clear the link there, and it did. Okay, so pandas as file. Instead of opening our file and using the dict reader method to read in the data, we can instead replace that with a pandas method. So now instead of doing it like this, we can simply say, so I'm going to get rid of this with context manager here, and since we got rid of that context manager, I'll unindent these other lines here. But now where we were opening that file, instead I can simply say data is equal to pd.read_csv and pass in the name of that CSV file, and it was data.csv. And now I can specify some columns. So I'm going to say that the ID, I'm going to create this IDs variable, and I'm going to say ID is the, let me see exactly what that column name was, responder ID. So I'll pass in responder ID there. So that's going to set this IDs variable equal to all of the IDs in that responder ID column. And we can do the same thing with the languages. So I'll call this variable lang_responses is equal to data, and we want the key to be in that responder ID column. And we can do the same thing with the languages. So I'll call this variable lang_responses is equal to data, and we want the key to be languages worked with. So I'll grab that. So, and we can do the same thing with the languages. So I'll call this variable lang_responses is equal to data, and we want the key to be languages worked with. So I'll grab that. So we still want our language counter, but now here for our loop, instead of saying or response call ID, it can just for opening context manager. Pandas, well, my pandas is really going to use the most pandas or anything like from the top horizontal bar text like X and Y. On our X languages, print JavaScript with 59,000 HTML data. So right above our row here, I'm going to make a variable, and I'm going to call this language_counter and set that equal to an empty counter. So right now, we only have the data for a single row, but we want to grab the exact, okay, so now that we have these lists here, let me exit that output there, and I'm also going to get rid of those print statements. So now that we have these lists, because we want to make by label themselves, so maybe you want the most popular language, right? That would be, if we put up import this, using pandas is to import reader method to read in the data. We can instead replace that with a pandas method. So now, instead of doing it like this, we can simply, and I'm going to see ID is the, let me see exactly what that column name was, responder ID. So I'll pass in responder ID there. So that's going to set this IDs variable equal to all of the IDs in that responder ID column. And we can do the same thing with the languages. So I'll call this variable lang_responses is equal to data, and we want the key to be languages worked with. So I'll grab that. So we still want our language counter, but now here for our loop, instead of saying for row and CSV reader, this doesn't exist anymore. Now we have this list of languages here. So I can just say for response in lang responses, update that counter. So that simple update to our code there should work exactly the way lang responses, update that counter. So that simple update to our code there should work exactly the way that it worked before. So if I save this and I run it, then whoops, name row is not defined. Okay, so yeah, I got an error here that says name row is not defined. I also meant to update this section here because there's no row anymore. So we just want to split the response instead. So response.split. Because remember, these lang responses here, when we're looping through these, each response is going to be this entire section here of all of the languages. So we can simply just split that response. Okay, so I'll save that and run it. And this should work exactly like it worked looked before. And we can see that it does. That looks pretty good. Now, like I was saying before, this is actually real world data that I grabbed from their actual survey. And I actually have those charts that Stack Overflow put together when they analyzed their survey data. So let me open those up and see if we got similar results. So I'm going to, okay, so here is their chart plotting out the exact same thing that we just plotted. Now, there could be some small differences here based on how I sanitized the data compared to how they sanitized it. But you can see that as far as the order goes, we got the same results. They've also styled their plot a bit further, but with a little customization, we could probably get something very similar. So it looks like almost analyze their run code directly in the browser. And that's a great way to complement watching my tutorials because you can apply what you've learned in their active problem solving environment. Hey there, how's it going, everybody? In this video, we're going to be learning how to create pie charts. And pie charts are pretty simple to use. They're similar to bar charts that we looked at in the last video, but instead of plotting certain values for each category, it's instead going to show us the proportion that each category contributes to a whole. So basically, just like the name implies, you can think of our chart as a pie, and each category will be a slice of that pie. And the larger the slice means that category has more of whatever values we're measuring. So let's go ahead. ahead and jump into this and see some examples. But real quick, I'd also like to mention that we do have a sponsor for this series of videos, and that is Brilliant.org. So I'd really like to thank Brilliant for sponsoring this series, and it would be great if you all could check them out using the but we don't have to follow. First of all, we need the values t. And I'll do a list of plt. I run that, then we can, not plot, sorry, plt.py, and we want to make a pie chart of those slices. So if I run that, then we can see that it plots out, takes up 40% some of that. So I'm going to go look at our chart. So pie chart, simply by saying labels is equal to 100% properties. So back in our code, after labels, this is going to be in the pie method. We can say wedge props for wedge properties. And this is going to be a dictionary of values. And we just want to change the edge color. So I'm going to type in edge color, and let's just set that to black. So if I run that, then now we can see that we have a black edge when before these were just a solid color here. Now, if you're wondering how I knew to change the edge color property there for that wedge property, that's something that I looked up in the documentation. And if you Google matplotlib wedge, then color, and let's just set that to black. So if I run that, then now we can see that we have a black edge when before these were just a solid color here. Now, if you're wondering how I knew to change the edge color property there for that wedge property, that's something that I looked up in the documentation. And if you Google matplotlib wedge, then it'll take you to their documentation page with all of the customizations that you can make. Okay, so lastly, let's look at how we can specify our own colors for these slices. And after we do that, then we'll take a look at a more real world example where we create a plot for popular programming languages. So to change the colors of these slices, we can do the same thing that we did with the labels and just create a new list corresponding with the colors that we want for each slice. So I'll just add a few extra colors here, and also let me add a few extra slices. So I'm going to pass in 30 and 20 here, and then I will also pass in labels for these, so just extra 1 and extra 2. Now, these aren't going to take up 60, 40 anymore, but that's okay. We're just doing a demonstration here. And now we want to pass in a list of corresponding colors. So I'll pass in, let's see, and now colors. So now we have that blue color. This is a blue hex clock to look good. Name color. Now, I have these available here in a snippets file that I have open. Here, let me delete those below as well. I'm just going to paste this over top of our custom colors from the Stack Overflow languages here. These because there's so much instead. If you have less than 5 items, then I think a pie chart would work fine. So with that said, let's strip down our data to only include the top 5 programming languages. So I'm going to go back to our code here, and now I'm just going to delete all of these up until the 5th item. So 1, 2, 3, 4, 5. So Java is the 5th, and then I will delete all the way up until the 5th item here. So 1, 2, 3, 4, 5. Okay. So now if we run this, then we can see that that looks a lot better than all of that clutter that we had before. Okay, so now let's see a few more things that we can do with this pie chart. So a lot of the times you'll see some pie charts that have an emphasis on one piece of the chart. So for example, let's say that that we were preparing a talk for a Python conference and we wanted to emphasize the Python slice on this chart. So to do this, we can pass in an explode argument, and this will be a list of values underneath will offset the slice. So to do this, okay, analyze that fraction, an example to explode it out here a little bit, and how if we were to, so I'll do a 0.5, then that would be really big, and it's exploded out by half the radius. The point here is at half, but I think that's way too large. So there are a few more arguments that we can add. A shadow equals true along our start angle is equal to, let's say, 90 degrees. So I will save that and run it. And now we can see that this chart was rotated a little bit. I think it picks an arbitrary angle to plot at first, and then this angle and get it lice is taking up in exactly how we like. So that's what start angle does. Okay, and lastly, if we want to actually display the percentage that each slice is taking up, I always need to look this up in here. So to do this, we can say this is going to be a percent sign there, 1.1f percent. And again, I know that syntax looks a little bit strange there, but that is the format string for how we specify a percentage. So if I save that and run it, and I forgot my comma there, so we had a syntax error. If I save that and run it, then now we can see that we have the percentages here within our pie chart telling us how big of a piece of the pie each of these values takes up. So that's pretty much of the article. But before we end, I'd like to also mention the sponsor of this video would be an excellent way to supplement. Hey there, how's it going? Everybody. In this video, we're going to be going over stack plots, and you may have also heard these called area plots. They're very similar to pie charts in the sense that they show you how the proportions of the different values contribute to the whole, but instead of doing this just once, like on a pie chart, a stack plot plot shows us this for a specific in just a bit. So with that said, let's go ahead and get started. So I have a little starting code here that you might recognize if you're continuing from my other previous videos, but if you're not, let me give a quick overview of this code and what's going on. Okay, so up here at the top, I am importing pyplot from matplotlib. I am using the 538 going to plot. And so these stack plots are really good for data where you want to track a total and also see the breakdown of that total by a specific category. So for example, let's say that you're playing a video game where you have teams and you want to keep track of the total points for the whole team for a stack plot. And I've got an example of this kind of data right here. So here's what this data represents. So we have a list here, a list so on to that point. So in the first minute, they all three scored a point. In the second minute, player one scored another point, so his total is 2, and so on. It goes all the way to the end point. Points and the 3 players had it, and entire start. We just have of minutes. Pass in time, which will array if your data is arranged that way, but ours are currently individual 1 by n lists. So we're just going to pass those in one at a time. So I'll pass in the player 1 list, the player 2 list, and lastly, the player 3 list. And that's all we need for a basic stack plot. So if I run this, then we can see here, let me make this a little larger. This is what a stack plot looks like. So we can see our minutes down here, 1 through 9, and then each color breaks up the points scored by each individual player. So we can see here in the first minute that the total stack plot comes up to 3 here. But then if we look at how many each individual player has, then that's 1 apiece. So we can see here by the end of the game that this blue section here, we don't have labels for this yet, but the blue section contributes the most, and then this red, and then this yellow. And we can easily add in labels to our plot just by passing in a list of desired labels into the labels argument. So let's go back to our code here. And I'm just going to say right above our stack plot here, I'm going to say labels is equal to, and we will make a list of 3 here. And I'm just going to copy in players 1, 2, 3 and put them here in these labels. And now in our stack plot, we can simply say labels is equal to that labels list. So, oh, and also real quick, I almost forgot, we also need to actually say plt.legend, and that will take those labels into account. So if I save that and run it, then now we can see that we get the legend for player 1, player 2, and player 3. Now the legend should try to pick the best location by default, but if it ever ends up in a location where you don't like it, then we can always hard code in at that location. So in this case, I feel like the upper left here would always be the best location for this specific data that we currently have. If your data was declining instead of increasing, then you'd probably want it in the upper right, but I'm going to hard code this to where it's in the upper left. So the way we can do that is within our legend method, we can simply say LOC for location and just pass in upper left as a string. So if I run that, then now we can see that looks a lot better. Now we have our legend up there in the top left of our stack plot. And just like some of the other plots we've seen, we can customize the colors the same way that we customize the labels by passing in a list of colors that correspond to the values that we want to have that color. So I have some custom hex colors down here at the bottom. So let's say that I wanted player 1 to be green, I wanted player 2 to be red, and I wanted player 3 to be blue. So I could create a colors list here, and let's pass in and they didn't. So in use case for a stack plot, you have a process in these variables here. The example that I know that we can plot these sort of from running that then you can give it a more specific, I'm going to say lower left. And now let me plot out. It's going to move this to the lower left. So let me make this a specific location by now lower left in the update main. That's why it's outlined here as play that it maintains a constant total. So what do I mean by that? Well, for example, let's say that you have a project and your team is only allowed to bill 8 hours to that project every day or something like that. So you could use a stat plot to track who's working on that project the most. So for example, let me grab some code from my snippets, and I have my snippets file here, and then I will talk about what this means. And I'm also going to have the snippets file available in the description section below if you would like to copy and paste this as well. So I'm just going to overwrite our old values there. Now I'm keeping these variables here as players and minutes just for simplicity, but we can think of this as days and developers instead of players. So the example that I have here could be an example of someone handing off a project off to 2 other developers over a course of time. So each index for all of these developers adds up to a total of 8 hours. And one of the developers slowly fades out while the other 2 are taking over that project. Now that might not be obvious just by looking at these numbers here, but that's why we have plots so that we can plot these sort of things out and we can see it visually instead of needing to pour through the data manually. Now I know I'm running, or I know from running this earlier that the legend is going to be in a bad spot here in the upper left. So instead, I'm just going to move this to the lower left. So instead of upper left, I'm going to say lower left. And now let me plot out this new data. So let me make this a little larger here. Now we can see that the legend is still a little wonky. If you still don't like the location of the legend, then you can give it a more specific location by passing in coordinates to place the bottom left corner. And if you want to see exactly how this works, then you can Google matplotlib legend, and it'll give you more details on how this works. But basically, if I go back to my legend here, instead of passing in a string, if I pass in a tuple, so let me pass in a tuple, I'll just do 0.07 and 0.05. And again, if you'd like to know exactly what that's doing, then you can Google matplotlib legend and take a more detailed look at exactly what those coordinates mean. But for now, let's just continue looking at our stack plot here. So let me rerun this. Now I think that legend is in a better location there. Let me make this a little larger. Basically what that tuple meant was that we are putting the bottom left of the legend 7% from the bottom or from the left and 5% from the bottom. So we can see that now we can kind of visualize that data a little bit better and see how one person's time fades out as the other 2 slowly add on. So we have player 1 here, which was our developer who had a full 8 hours on this project in the first day here. And then as he moved on, he had 6 in the second day. It looks like the other 2 picked up 1 hour at a time here. And then slowly it looks like the red player 2 here, developer 2, picked up more time in this project than player 3. But then at the end, they both have 4 hours apiece. So that's an overview of how these stack plots will work and the types of data that you would use with these stack plots. Like I said, it's great for visualizing these things over a certain amount of time and breaking down the total into individual parts over that course of time. Okay, so we're just about finished up here, but before we end, I'd like to mention the sponsor of this video, and that is Brilliant.org. Brilliant is a problem-solving website that helps you understand underlying concepts by actively working through guided lessons. They have computer science courses ranging from algorithms and data structures to machine learning and neural networks. They even have Hey there, how's it going, everybody? In this video, we're going to be revisiting line plots like we saw in the very first video, but this time we're going to add to them by adding in fills. Now, fills are great not only for making our plots look nice and professional, but also they can give us some useful insights depending on how we use them. So, for example, we can use conditional fills that will show us what areas of our line plot fall above or below a certain threshold. So, I think the best way to learn is for us to just jump in and start looking at some examples. Now, I would like to mention that we do have a sponsor for this series of videos, and that is section 4. We are also importing PyPlot from matplotlib. Here, we are bringing in some data from a CSV file, and I'll look at this in just a second and show you exactly how that's working. But continuing on, we are also doing plt.plot. So this will do a line plot, and these are our ages and developer salaries here. Again, we'll take a look at this data in just a second. We have another plt.plot. So this will be a second line on our line chart. Now we also have plt.legend to show these labels. We're also giving our plot a title, our x-axis a label, our y-axis a label. Tight layout just changes the padding around where it looks a little nicer. And plt.show actually shows our plot. So that's a quick overview there. And all of this code and this data.csv file will be available for download in the description section below. And I'll put this up on my GitHub if you'd like to copy and paste into your editor and follow along with this. So here we are reading in this data from this CSV file, and we are reading this in from data.csv. So let me show you what this data.csv file looks like. So the data within this data.csv file are the ages, so 18, 19, 20, 21, and then these other columns here, we have all devs, Python, and JavaScript. So these are the median salaries for that age. So for age of 18, the median salary for all developers who answered the survey was this number here. The median salary for all the people who said they knew Python was this number here, and so on. So I'm going to go back to my code here. So when we load this in using pandas, when we say ages is equal to data age, all that's doing is grabbing that age column. So our ages variable is going to be equal to 18, 19, 20, 21, and so on. Same thing for our dev salaries. We're reading in that all devs column. Py salaries, we're reading in that Python column, and JS salaries, we're reading in that JavaScript column. Okay, and down here, we saw these line plots in the very first video of this series, but this is plotting out the salary or the median salaries for all of our developers here. And then we're adding in a custom color and style here as well, also giving it a label. And we're also plotting out the Python median salaries here as well. So if I run this with those plots, then this should be similar to what we saw in the very first video. We don't have JavaScript on there right now. I'm only going to work with Python and all developers so that we can kind of see what's going on here a little bit better. Okay, but we've already seen these line plots here, so we kind of know already what that's all about. So now let's see how we can add in some fills to our plot. Now we'll start off with a simple one here to just see what this looks like. So let's say that we wanted to fill the entire area underneath our Python plotted data. So to do this, here above plot.legend, we can create a fill for our plot simply by saying plt.fill_between. And now we're going to pass in our x-axis. So that was ages, just like our other plots here. And now we want to say what we want to fill between. So I want to fill between the Python salaries here. So I'll pass in Py salaries. And now I'm not going to pass in anything else. Now we can pass in an additional parameter here and say that I want to fill between, Py salaries and dev salaries, for example. But the y2, this is called y2, this is set to 0 by default. So if we don't put anything in there, then it's just going to fill between our Python salaries all the way down to the bottom. So let me run this just to show you what this looks like. So now we can see that our Python plot here has a fill from our Python line all the way down here to the bottom. But we can see it's also interfering here a bit with our other plotted line. So to make this look a little bit better, let's put an alpha on our fill so that we can see through this a bit better. So back here in the plot, I'm just going to say alpha, and this is how much we can see through it. I'm just going to say 0.25. So now if I run that, then we can see that now that looks a little bit better there. Okay, so I feel like just filling in our line plots with an alpha here just makes our plots look a little bit better. But if we use these with conditional thresholds, then it can also give us some useful information and some feedback as well. So let's see an example of this. So right now, our fill is defaulting to 0, which means it's filling between our y values, our Python plot, and 0 all the way down here at the bottom. But we can change that. So I have the overall median salary for all developers who answered the survey, and I have that commented out here. So instead of using 0, let's say that we wanted to fill between this overall median and our Python salaries. So to do that, we could just pass that in as that third argument, which is the y2 value that I was telling you about, and that will fill that in instead of defaulting to 0. So I'm going to pass that in as the third value there, and now let's run this plot. So now we can see that instead of plotting at 0, that overall median was 57,000. So now it's showing us exactly where our Python plot crossed that overall median. median was 57,000. So now it's showing us exactly where our Python plot crossed that overall median salary. So when our Python plot is below the overall median salary, it fills up to that point. And when our plot is above the overall median salary, it fills down to that point. So that actually gives us some nice feedback. And we can even put in some additional conditionals here so that it only fills when that condition is met. So let's look at an example of that. Let's say that we wanted one fill with the color set to green when we are above this median salary and another when it is below. So we'll say red or something like that. So to do that, we can say, I'm going to go to a new line here. Now we're actually going to add in another argument here, and this is going to be a where. So I'm going to say where, and we're going to set this equal to. This will be where pi salaries are greater than the overall median, okay? Over, so I'm going to say flipped, and that all. So if I run the condition at the same time, so we can see here with that where clause that we are only doing that fill where our Python plot is above that overall median salary, but where it's below, it's no longer plotting up to that point. So if we want to fill in the area that's below the overall all of the salary, I'm just going to say less than or equal to instead. And I think with this current color scheme, that this first fill between is blue and this first fill between, or in the second fill between here is red. So let's go ahead and run that and see what that looks like. Okay, it's not quite red. It's kind of orange, but I think fill between here is red. So let's go ahead and run that and see what that looks like. Okay, it's not first fill between, or in the second fill between here is red. So now methods. Now, if we do want to customize the colors, then we can do that. Have a custom in red. So then that orange color value to fill in the fill between methods instead of using this over line on our plot, and I'm going to pass that in. It's filling in the areas between under those dev salaries. So now if I run this, then we can see that now those dev salaries and this one to be under those dev salaries. So it's here. So I'm going to change this query to be over as our third value here. And I also want to change my queries here. So I'm going to change this query to be over those dev salaries and this one to be under those dev salaries. So now if I run this, then we can see that now it's filling in the areas between those two plots. So now if I run this query to be over those dev salaries and this one to be under those dev salaries. So now if I run this, then we can see that now it's filling in the areas between those two plots. So we don't actually have a lot of red here because it doesn't really dip below the other one. I don't know if it dips below right here. Go in 45,000 and stuff like where we're in the blue. As those sections will be a good idea to label these filled sections. I'm just going to mention here. I'd like to mention you get hints, of course, in my tutorials because you can apply what you've. Hey there, how's it going, everybody? In this video. So we're going to be learning how to plot histograms. But a histogram groups the data up into bins instead of you have a sponsor plotting each individual within certain boundaries. It's a lot like a bar graph, but a histogram groups the data up into bins instead of plotting each individual value. So the best way to see what this looks like is to just take a look at some examples. Now, I would like to mention that we do have a sponsor for the series of videos, and that is Brilliant and Supporter that you might recognize if you're okay. So update style for just to make our plots look a little nicer. And here is the data that I'm going to be using for this video. Right now, I just have a list of ages here between 18 and 55. Here's some data that I have commented out in a CSV file, and we'll look at this once we get further along in the video. video and see how to plot out more data than just this small list. Okay, so down here at the bottom, we are also creating a title for our plot. We have X and Y axis labels. We have a tight layout, which just gives our plot some padding. And also we are doing plot.show, which will actually show our plot. Now, as usual, if you'd like to follow along, then I will have this code available on my GitHub, and there's a link to that in the description section below if you want to go there and copy and paste this into your editor so that you can follow along with this exact data. And I'm also going to have the data.csv file that I'm using in this video as well. Okay, so like I was saying, we're first going to look at how to do this using this list of data directly here in the Python script, and then we'll look at a real world example with data that I'll load in from a CSV file. So first, let's look at this small list of sample data. So let's pretend that we took a survey and we tracked the ages of all the people who responded. Now, it might be useful to plot those ages to get an idea of which age groups are in our sample size. So how should we actually plot these? Well, off the top of your head, you might think that a bar chart would be a good idea for this. But if you think about it, we possibly have up to 100 different possible ages, maybe even more. So if you plotted out how many responses we got from each age, then that would mean you'd have almost 100 different columns, which definitely isn't useful. So this is where histograms come in. Histograms allow us to create bins for our data. And now it might be useful to plot those ages to get an idea of which age groups are in our sample size. So how should we actually plot these? Well, off the top of your head, you might think that a bar chart would be a good idea for this. But if you think about it, we possibly have up to 100 different possible ages, maybe even more. So if you plotted out how many responses we got from each age, then that would mean you'd have almost 100 different columns, which definitely isn't useful. So this is where histograms come in. Histograms allow us to create bins for our data and plot how many values fall into those bins. So to see this, let's create a histogram of this list of ages that we have here. So to do this, I can simply say plt.hist, and we will plot out those ages. Now, if I ran this now, then it would give us a plot, but really we wouldn't know what bins it's actually using. So I always like to pass those in manually and explicitly so that people know what those bins are. So when we specify bins, we can either pass in an integer or a list of values. If we pass in an integer, then it will just make that number of bins and divide our data into those accordingly. So for example, if I was to say bins is equal to 5, then this will divide all of these ages up into 5 different bins and then tell us how many people fell into those age ranges. So if we run this, then we can see that we get a pretty simple histogram here. And what this is a distribution here. Now, I personally find it a bit difficult to read these sometimes if we don't have edge colors for each bin because they all just kind of run together here. So I don't know exactly how many bins there are here and here. I'm guessing since we have 5 bins, it's 2 bins here and 3 bins here. But let's add in some edge colors so that's more clear. So we can add those in by going back to our plot here. And I'm just going to pass that as an argument. So edge color is equal to, I'll just say black. So now let's run this. And now we can see those bins a bit more clearly. So let me make this a little larger and also to where you can see the ages up here at the top. Let me explain more clearly is equal to, I'll just say black. So now let's run this. And now we can see those bins a bit more clearly. So let me make this a little larger and also to where you can see the ages up here at the top. And let me explain what this is actually doing. So we said that we wanted our data plotted on a histogram and we wanted that broken up into 5 different bins. So it calculated those ages for us. So this looks like it's between, let's see, 18 and like 26 maybe, and then 26 to like 33 and so on. But what this is telling us here is that there are 4 people in our ages here that fall between 18 to 26. And there are 4 people that fall between 26 to 33 and so on. And then we just have 1 person in these higher age ranges for each of those bins. So if you pass in an integer for our bins, then that's what we get. But we can also pass in our own list of values, and those values will be the bins. And I like passing in a list of bins for this kind of data because you have more control over the exact values. So for example, let's say that I wanted to plot the ages broken up into groups of 10-year differences. So I could say right here above my plot, I'm going to say bins is equal to, and I'm just going to say that we want a bin for 10, 20, 30, 40, 50, and 60. And now, instead of passing in that we want 5 bins, I want to say that I want to use this list as my bins. So now if I run this, then we can see that we still get 5 different bins here, but that's only because we have 6 values here in our list. So it starts at 10, and then 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60. So that is 5 bins total. So if I open this back up, now the reason I like using my own bins for this kind of data is because now it doesn't have to try to guess where I want these broken up. So we can see that now we have from 10 to 20. It's a lot easier to read. We don't have to guess it's like 26 or something like that. So we're saying from 10 to 20, 2 people in our ages list fell into that bin. There were 4 people from 20 to 30, 3 from 30 to 40, 1 from 40 to 50, and 1 from 50 to 60. So that's how you plot and read a histogram. And we can even exclude some data if we don't want to add those ranges to our bins. So for example, let's say that we didn't want to include the ages between 10 to 20 in my results. Well, to do that, we can just simply remove 10 from the bin. And now 20 will be that leftmost value. So now, if we run this, then now we can see that it's not from the bin. And now 20 will be that leftmost value. So now, if we run this, then now we can see that it's not even plotting out the ages from 10 to 20 there. So this 19 and 20 don't even show up in our results here. So this is now just giving us our results for the people who fell into these age ranges between 20 and 60. Okay, so now that we've looked at this small example, now let's look at a real world example looking at some real data. So let me uncomment what I've got here. Let me remove ages here. So I'm just going to remove that data that is directly in our Python script. Now I'm going to uncomment out the data that I had down here. Let me cut that out and paste it here above our bins and our plot. Okay, so I'm loading in this data.csv file, and I'm using this pandas.readcsv method to do this. Now, we've done this a few times so far in the series, but if this is your first video, and the data for people, this data people fall in 40. Just weren't many scales true to our plot. So within our hist method, I'm just going to say log is equal to true. And now if I run this, then this is plotting this on a logarithmic scale. And we can see that now we do have that data visible for 70 to 80, 80 to 90, and 90 to 100. So we actually had more people who responded to the survey that they were between the ages of 90 to 100 than the people who were between 80 and 90. So I think that's kind of interesting there. Now, sometimes you might find it useful to add some additional information within these plots as well. So for example, let's just leave the histogram how we have it for now. But let's say that we want to plot a vertical line where the median age of all the respondents is. And I've got this commented out down here at the bottom here. So let me uncomment out this median age. And also I'm going to uncomment this color and this legend as well. So I went through and I calculated the median age of all of the respondents, and it was 29 years old. So now let's plot a vertical line on our existing plot with that age. So to do that, just above our legend here, I want to say plt.axv line. So I'm pretty sure that is stands for axis vertical line. And we want that line to be plotted at the median age. And now let's also, I'm going to add in a color here, and the custom color I'm going to add as this, I'm going to say age median. So now let's run this. So this plot tells us a lot of things. It tells us how many people are falling within which age groups, who age. Run this, a label, so that we know some color. I'm going to add as this. I think this is just a red color that I grabbed. And also let's put in a label so that we know what this line represents. And I'm just going to say age median. So now let's run this. And now we can see that within our histogram, we now have this vertical line here, which is the age median. So this plot tells us a lot of things. It tells us how many people are falling within which age groups who answered the survey, and also where the median is for those survey results. And if you think that this line is a little bit thick and kind of obstructing the data anyway, then you can play around with how this looks. So for example, if you wanted to change the thickness there, instead we could say line width is equal to 2. If I run that, then that's a little thinner there. So that's basically what these histogram plots are used for. We can use these for dropping our data into these different bins and see how many values fall into these certain bins. So that's what you would use a histogram for. Okay, so we are just about finished up here, but before we end, I'd like to mention the sponsor of this video, and that is Hey there, how's it going, everybody? In this video, we're going to be going over scatter plots. So scatter plots are great when you want to show the relationship between two sets of values and see if they are correlated. So first, we're going to look at a basic example of a scatter plot using some data within our Python script here, and then we'll look at some real-world data that I have within a CSV file. And the data within the CSV file are the views and likes of YouTube videos on the trending page the day that I made this video. So that might be interesting to plot out. Now, I would like to mention that we have a sponsor for this series of videos. Green, I want it to be equal to colors. So now, so to create a scatter plot out of these values, it's as simple as saying plt.scatter. And we want to do our x and our y values. So if I run this, then let me make this a little larger here, then we can see that we have a scatter plot of these random values. Now, scatter plots are really nice for seeing different trends or outliers or things like that. Now, since these are random, then we don't really have any trends here, but sometimes that's important to know also, that there's not a trend. So our scatter plot, since it looks random like this, then this likely tells us that there's no correlation between our two lists of random values. And we'll see data set here in a bit that is more correlated with the values. But for now, let's look at some basic customizations that we can make to our scatter plot. So first of all, I feel like the sizes of the dots here are a bit small on this plot, and you can change that by setting the size. And that is an S argument. So we'll set S equal to, these sizes are always a bit weird. I have to always look up in the documentation how these are related. But if we run this, then now we can see that these dots are a little bit larger here on our scatter plot. Now, if you bump that up to like 500 or something, then it would really be noticeable. So we can also change the color and the marker styles of these plots as well. So to change the color, we can and simply pass in styles that we can use as well. I'm going to leave a link, but for example, equal to x's. So if we save that and we run it, then we can see that now we have green. I could simply say marker is equal to style, and there are underlying x. And we run that out now, and just we add an edge, and for the color is equal to a bit. So to show you what this looks like, let me add an edge and a color. So I'll say edge color is equal to, we'll just set that equal to black. That's going to be the edges of the circles. And for the line width, let's also set the line width. It's as easy as just saying alpha is equal to alpha to our color so that it's also set the line width of that edge equal to alpha is equal to that these dots with these black edges looks a lot better. Now, if your color is a bit too soft, then you can always play around with that alpha. Okay, so another thing that I want to show you is how the colors and sizes can actually be on a per mark basis rather than applying them to all of the marks. So actually allows us to add additional data sets into our plot. So for example, let's say that we have our current plot that we just looked at, but we wanted to add some additional information. So for example, let's pretend that our current plot that we just surveyed data about a bunch of people, and we wanted to break down the data further into something more specific. So for example, let's say that we had these people rate something from 1 to 10, and we wanted to somehow plot their rating as well. Well, to do that, we could simply assign different numbers to these different possibilities, and those will then give you different. So let me this out. Okay, so the numbers in this colors list, these are numbers between 1 and 10. Now, like I said before, maybe this could be a person's answer to how satisfied they are with a certain product or something like that. And so each of these values will correspond to a data point in our X and Y variables. So now if we pass this into our scatter method as the color argument, so I'm going to say, whoops, I accidentally repasted that. I'm going to say C, instead of being equal to green, I want it to be equal to colors. So now I'm going to run this. Then we can see that we get different color dots. So what this is doing here is whenever we plot this X and Y value here of 5 and 7, it also has a color of 7. And these different colors here, 7, 5, 9, all of those are going to correspond to different colors here on our chart. Now, I really don't like the colors that we're getting here. These are just shades of gray. We can actually change these by using a color map. And just like the marker symbols, there are a ton of built-in color maps that we can use. And I'll be sure to leave a link in the description section below to all of the color map options. If you'd like your colors, be sure I put in of green as the intensity. So I think these represented colors represent. So you can just say C bar is equal to C bar, like a color bar here on the, okay, better color ones and other things to add as sizes there. And now if we run this, then we can see that now each of these individual plots have sample data here. I pulled out some real world data from a and I wanted to, so let me pull up this CSV file here and let's see what this looks like. So I've got that CSV file. Hey there, how's it going, everybody? In this video, we're going to be looking over time series data and plotting dates in Matplotlib. Now, there's a ton of data out there that contains date information, so knowing how to plot this properly is definitely going to be a huge help when creating these graphs. So first, we're going to look at some basic examples using some dates that I have directly here within my Python code, and then we'll see an example using data from a CSV file. And the data within the CSV file are Bitcoin prices over a couple of weeks. Now, I would like to mention that we do have a sponsor for the series of videos, section below, sample code pulled up here in my script. So first, we'll look at these time series plots using this list of data directly in my script, and then we'll look at a real-world example with data that I'll load in from a CSV file. Now, if you've been following along with the series, then you'll likely recognize a lot of the other Matplotlib code that I have here at the moment. But if not, then let me go over all this real quick. So here at the top, we have some imports. So we're importing pandas. We're also importing date time from the standard library and time deltas. We are importing pyplot from Matplotlib. And we're also importing dates from Matplotlib. And we're importing that as MPL dates because I was afraid I was going to overwrite it with a variable like I did here called this dates. We are also using a style here. We're using Seaborn style with Matplotlib. These are the data that we're going to be using, but I'm going to gloss over this for now and just point out the rest of this code here. We have a plt.tight layout here that adds a padding to our plot, and plt.show will just show us our plot. And we'll go over this other data once we are actually ready to plot that. And as usual, all this is going to be available for download on my GitHub, and there's a link to that in the description section below if anyone would like to copy and paste this into their editor and follow along with this series. Okay, so for my sample data here, I've got a list of 7 dates, and I'm using Python's built-in datetime module to create these. So these are just 7 days back to back. And then below, I've got a Y variable here for simply future change in pandas that will be taken here out. Run this. Then we can see here that it plots those out. Now, if you get some warnings in your output down here, then don't worry about that. Mine is just warning me about some future change in pandas that will be taken. But by default, this plot has markers instead of being connected by a line. But we can fix that easily just by so now we can see that these are, I'm going to go ahead and now connect line style of this plot to be solid. So now, if I run that, I'm going to make this line. And if you wanted to, then you could also go ahead and turn off these markers by setting marker to none, but I'm going to go ahead and leave those here for now. Better. So one way that we can do this is to run the auto format x date method on our figure. And this will rotate our dates so that they fit a bit nicer and change their alignments and things like that. Now, we haven't talked much about figures and axes in this series yet. That is going to be in the subplots video in a couple more videos. But basically, this is going to be a method on our figure and not on this pyplot object that we have been using. So to get the current figure from pyplot, we can say plt.gcf, which is get current figure. And now to run this auto format method, we can just run it on that current figure and say auto fmt for format, then underscore x date. Okay, so now if I run this, then we can see that now these dates are rotated and they have different. Okay, so now if I run this, then we can see that now FMT for format, then underscore X date. Okay, alignments. Got that auto formatting in place. Let's also see how we can change the format of our date. Wanted them to port date, passing in any documentation that we want. %, lowercase b, and then force of the year. Now we need to method figure format correctly. I have now in a CSV file this code that I have here at the bottom. So I'm going to copy these two lines here and in the other tab. Hold off. Okay, and date and the price. So I'm going to as date. So as the D2 time. So what we're doing here, do that, but based on content courses in different fields of mathematics or. Hey there, how's it going, everybody? In this video, we're going to be plotting data that's continuously being generated in real time. So these real-time plots would be great for plotting data that is changing frequently that you want to monitor. So for example, I see a lot of examples on certain sites that will, plot things like real-time YouTube subscriber counts, or maybe you're reading in data from a sensor and want that immediate feedback. No matter what you're doing, you're likely going to find a use for something like this. So first, we're going to look at a basic example where I plot some data that's directly in my Python script so that we can wrap our heads around how this is working. And then we'll look at a real-world example where we're actually monitoring a CSV file. Now, if you're pulling data from a real-time API or a sensor of some kind, then it's pretty common to write those results to a CSV file. So we'll monitor that for changes and make updates to our plot when there's new data available. Now, I would like to mention that we do have a sponsor for this series of videos, and that is brilliant.org. Our code script that we're going to be plotting. We're doing PLT, get our heads wrapped around layout, link in the description with, for example, but now let line chart. So if I run that, then we can see that works. So that is pretty simple. But now let me delete the current data that we have in these lists, and I'll uncomment out this function that I have right here and explain what our desired outcome is. So let me remove plt.plot, and for our x and y values, I'm just going to set these to be empty lists. And now let me uncomment out our index and our function here. So for anyone who has never used the count function from the itertools library, basically by default, it just counts up one number at a time, and each time we get the next value. So I have a function here called animate, and within this function, we are appending to our x values list and also our y values list. Now, x values is just going to append a value that is just going to count up by 1. So it's just going to be sequential. And y values is appending a random number here between 1 and 5, or between 0 and 5. So let's say that, well, how would we do that? So to do that, we can use the func animation class from the matplotlib, say from. Now, down here below our function, let me make sure I spelled all that correctly. Yep. So down here below interval. So is equal to animate from our current plot. And to do that, we need to and also can pass in one per run for our animation. So that was the, okay. And next, we need to pass in the function that we want to run for our animation. So that was the animate function. And also the interval for how often we want to run this function. The interval is in milliseconds. So if you want 1 second, then you can pass in 1,000. And I think 1 second would be good for us in this video, but you can change that depending on. So now within the and we will plot out those x values. Going to be one big problem. So let me run this. Now, if we run it like this, then it will somewhat work, but there's going to be one big problem. So let me run this and I'll show you what that problem is. So if we run this, we can see that we get an updating chart, but you can see here that this is weird. We're getting all kinds of different colors here. So let me close this and I'll explain what's going on here. So the reason it's doing that is because our plot method is actually plotting a brand new line every time, but it's not clearing out the old lines. So there are actually multiple lines getting stacked on top of each other there, but they're just being covered up, so you can't really tell. So one way we could solve this is to simply clear out our axis. And if we do that, plot the same axis. And now goes random, I run this. Then we can see that this looks better. It's updating our plot with those random values. So I'm going to say PLT, which I'm assuming stands for clear, same color. So to clear the axis, we can simply run these. The CLA multi of how this would help. So to do this, I'm going to plot data that's from a CSV, and this CSV is going to be constantly updated by an outside source. Now, this source could be anything like the data is in this file, keep appending to the CSV, and we are creating those headers. And A is testing there. We are monitoring means that it's also subscriber count access there. This, there are access saying PL coming in. This is picking up file and plot every 5. That would be a better chance to run and initialize the snippets for this video when I upload those to. Hey there, how's it going, everybody? In this video, we're going to be going over subplots. So far in this series, we've simply been creating our plots with the PyPlot object, and that works great for what we've done so far. But if you want additional plots, or if you want to work with plots in a more object-oriented manner, then it's best to create your plots with the subplots method. A lot of people prefer to create their plots this way, even if they're only creating a single plot. So in this video, we're going to see how to create our plots using the subplots method, and go back over some of the plots that we created earlier in the series, and see what changes need to be made in order to use subplots for those examples. Now, I would like to mention that we do have a sponsor for this series of videos, and that is Brilliant.org. So I really want to thank Brilliant for sponsoring this series, and it would be great if you all could go and check them out using the link in the description section below and support the sponsors. And I'll talk more about their services in just a bit. So with that said, let's go ahead and get started. Okay, so I've got some sample code pulled up here in my script, and if you've been following along with the series, then you'll likely recognize the other matplotlib code that I have here at the moment. But if not, then let me go over this really quick. So this is actually a plot that I created in the first video of the series, but we're loading in this data using a CSV file here instead. Okay, so let me go over this. So first, we're importing pandas here at the top. Then we're also importing the PyPlot module from matplotlib. We are using the Seaborn style for these plots to just make them look a little bit better here. And now we're loading in this data from this CSV file using pandas read CSV method. So what this is doing is it's going and getting the age column from that CSV file, which if we look at this CSV file, these are the median salaries for these ages for the respondents who answered this survey. So for age 18, these are all the median salaries, 19 median salaries, and so on. So our ages here, when we say data is equal to column, we're giving means earlier in the series. Okay, so is it has to work with this video. The pipe to get rid moment, a certain of the places of using with the Y label, everything else, the AX, and run it. So why is this broken up into multiple plots?
You are in the right place to learn to become a data analyst. In this massive boot camp, Alex the Analyst will cover all the core topics that data analysts need to know. And along the way, you'll build plenty of projects to gain hands-on experience.
Hello everybody, my name is Alex Freeberg, better known as Alex the Analyst on YouTube. And in this video, you're gonna be taking my entire data analyst bootcamp. This bootcamp is comprised of videos that I've made over the past 3 years, and they cover a lot of different topics like SQL, Excel, Power BI, Tableau, and Python. Throughout the bootcamp, there are a lot of hands-on guided projects that will really help you learn these skills well. And speaking of projects, there's an entire part near the end where you can build a free portfolio website where you can put all of your projects on so that hiring managers and recruiters can go and look at all these projects that you've built. If you wanted to go even more in depth into the skills that we learned in this bootcamp, I have a data analytics learning platform called Analyst Builder. Analyst Builder was designed specifically for data analysts, so all of the courses and all of the content are just for you. And it has a coding section where you can learn and practice for technical interviews. And lastly, before we jump into the bootcamp, I want to give a huge shout out to Free Code Camp for putting the I don't know why I did so many spaces. Drop table if I recommend keeping, and that is actually legally bound, like 11-2-2001, which is as simple as that, or the highest total amount sold. So that would be paper. Do we want to add? So we to actually get very simple. All right. So this is what we want to do from the left in our video on. Again, we're working on a very small computer. Now, if we run that would be our here. Please don't do this. We wanted to change like we want, and then we're going to append that to this original data frame. I already did the most popular and the best to do, or that we should do, is upload or import our libraries. So I'm going to say import. Oops, what am I doing? It's off to a terrible start. There we go. Import libraries. Now, I'm not going to write out all the libraries. I have some things that I'm going to be copying and pasting throughout this. There's only a few things that I'm copying and pasting. You can take a quick glance. Some of the things that I just don't want to waste time on, because this could be a long video. I don't know. I don't want to waste time on stuff like this. And so
Learn how to use Python to analyze astronomical data. This is a great real-world use case to help you improve your data analysis skills. The course offers a practical, hands-on approach to simplifying complex.
I need to do is capital, right? To expand or to engine different kind of pieces of puzzles which you are going to combine in some
of information in as per the formula gives us 0.01
and make a decision through
26.9.
Change the borrow
crisis is in its early days, and it is hard to predict what works. Started to the other
1900 one we need to have to make light of Python with realizations and finally design, create and maintain
Hadoop.
few companies.
so in job descriptions or the roles of a data analyst. So it depends important role ID data preparation and data
From the applications, websites, etc. So being named framework.
And this example is
So at number 10 we have statistics. To become a full-fledged data analyst, a thorough grounding in statistics is essential. Being good at statistics will help you understand algorithms.
Partitions created for this particular file, and I can also be looking improve the we need to do. Once this is done, we'll simply learn folders. We can always check that, so I can
But the Spark works as resilient
Let's to the important
change all of the query mode to the Spark SQL way. Now Spark SQL came. Now check, let's quickly systems practical. Now if you
my terminal.
video now.
Next slide. Great parameters, and now what's command is how to again go ahead and produce of the code into comma localhost colon 90. The replication
Of data processing.
function, then view the now you have
notes Spark of map, so it's going to apply a function. So within map,
Hello guys, this is Siddharthan.
Place to astronomical data. This is
List of elements that
Hello everyone, this is Siddharthan. This is our fourth project video, and in this video we are going to see how we can build a house price prediction system using machine learning. Okay, so this is a complete hands-on video, and we will be doing all our programming in Python. And for this prediction system, we will be using a XGBoost regression algorithm. Okay, so this house price prediction is a regression problem. Okay, so first of all, let's try to understand. Hello everyone, this is Siddharthan. This is our fourth project video, and in this video we are going to see how we can build a house price prediction system using machine learning. Okay, so this is a complete hands-on video, and we will be doing all our programming in Python. And for this prediction system, we will be using a XGBoost regression algorithm. Okay, so this house price prediction is a regression problem. Okay, so first of all, let's try to understand more about this problem statement. Then we will discuss what is the approach we will be taking to solve this problem, and then we will get into the coding part. Okay. So first of all, let's understand what is meant by regression. Okay, so generally machine learning is classified into two types. They are supervised learning and unsupervised learning. In supervised learning, we will train our machine learning model with lots of data. Okay, so these data are labeled data. So we will be provided with labels. So in this house price prediction case, the label is nothing but the price of the houses. So because the price is what we are trying to predict, right? So that will be our label. Okay, so in the case of unsupervised learning, so we will be training our machine learning model without this label. Okay, so this supervised learning is further classified into classification and regression. So you can see what is meant by classification and regression in this slide. So basically, classification is about predicting a class or discrete value. Okay, so the previous video, the project video we have seen is about predicting whether a person has diabetes or not. So this is a classification problem because we are just predicting the case is either this or that. But in the case of regression, we want to predict a continuous value, a number or a quantity. Okay, as in the case of this project where we want to predict the house price. Okay, so this is not some kind of classification, but we want an actual number. Okay, so these problems are nothing but regression problems. So this house price prediction is a regression problem. Okay, so let's try to understand more about our data set. Then we will see what is the workflow we will be following. Okay, so I have given a sample data for our data set, and above statement is the description of this data set. Of course, so this is basically the Boston house price data set. So we know that Boston is a famous city in the United States. So this data set basically contains 506 entries and 14 features. Okay, so you can see the columns in this sample data set. So the last column represents the price. So the price values are in the thousands of dollars. Okay, so for example, you can see the last value in the first row, which represents 24, right below the price. So it represents $24,000. Okay, so the unit is $1,000. So likewise, we have lots of columns here, right? So the first column represents CRIM. So CRIM basically means the per capita crime rate by town, and ZN represents the proportion of residential land zone for over 25,000 square feet. And here we have this NOx column, right? So it represents the amount of nitrogen oxide concentration. So likewise, there are various columns and features. Okay, so the tax represents the amount of tax and all those things. So you can understand more about this data set in either use a machine learning repository or in Kaggle. Okay, so you just can search as Kaggle house price data set. So you will find the description of this data set. Okay, so there you can find what all those columns means. So basically we have 14 columns in this. If we give the first 13 column, the value of first 13 column, our machine learning model should predict the price of the house. So this is the goal of this project. Okay, so now let's see how we can solve this problem. So this is the workload. So first, of course, we need this Boston house price data. Okay, so what we need to do is we cannot feed this data directly to our machine learning model. Okay, so we need to do a lot of processing before we can do that. So we need to do the data pre-processing steps. Okay, so in this step we will feed our data to a data frame, and in the data frame we will do some processing. Okay, so by that processing our data will be suitable and compatible to feed to the machine learning model. Okay, so once we process the data, we have to do some basic analysis on the data. So we need to find the correlation between various features. So we have seen that the data set has 13 features, right? 13 features and one price column. So we can try to see which 13 of these features are interrelated. Okay, so that we will be doing in the data analysis step. So once we have some basic data analysis done, we can split the data set into training data and testing data. Okay, so this is called as train test split. So we will feed this training data to our XGBoost regressor algorithm. Okay, so and we will evaluate our model with the help of testing data. Okay, so these are two data splitted from our original data set, because the training has to be done with one type of data and the testing has to be done with new data. Okay, so that's why we are splitting it. So and XGBoost regressor is a decision tree kind of classification algorithm. Okay, so it is very much useful for regression cases. So this XGBoost regressor. Okay, so there is also XGBoost classifier and also XGBoost regressor, as our problem statement is a regression where we need to predict a continuous value or a numerical value, which is the price. We used a regressor model. Okay, so this is the workflow we will be following. Okay, so now let's get into the coding part of this use case. So I'll close this slide. So in Google, just search for Google Colab. Okay, so we will be doing all the programming in Google Collaboratory. Okay, so Google Collaboratory is a Python environment where we can do Python programming. So I have made a complete video on Colab basics about various features. House price prediction. Okay, so you need to connect the system here. So this basically is a cloud-based environment where you can run Python programs. Okay, so we will get connected to a backend Google servers, and all the programming we are doing here will be run on those Google servers. So it is completely free, and it is very much useful for machine learning and data science applications. So you can check the amount of RAM and disk space you are allocated to. So we have a RAM of about 12 GB and disk space of 100 GB, which is really good. So this is where we will be doing all the Python programs. So this is called a cell. Okay, so now we can start the programming for our house price prediction. So you can write the code in this code cell, or you can create a text cell where you can make some comments about your code. So what basically you are doing in that particular cell. Okay, so first of all, we need to import the dependencies. The dependencies are nothing but the libraries and functions we will be needing for this use case. Okay, so I'll make the text here as importing the dependencies. Okay, so importing the dependencies, you can press shift plus enter to run that particular cell and go to the next cell. Okay, so first of all, let's import numpy. So import numpy as np. Okay, so numpy is very much useful for making arrays. Okay, so those arrays are called as numpy arrays, and then we need to import pandas as pd. So pandas is useful for making the data frame. Okay, so pandas as pd, and import matplotlib.pyplot as plt. So matplotlib is very much useful for making plots and graphs, and we need another library for plotting, which is cbound. So import cbound as sns. Okay, and now we need to import sklearn.dataset. So import. So sklearn is a very important machine learning library from which we will get few datasets and a lot of machine learning algorithms and other functions. Okay, so sklearn.datasets. Through this datasets module, we can get that Boston house price data. Okay, so we need to import sklearn.datasets. Okay, now we need to import the function train test split. So this function is used to split our original data into training data and text data. Okay, so import. Okay, so not import, just given us from sklearn.model selection import train test split. Okay, and then we need to import our XGBoost regressor algorithm. So from XGBoost, import XGB regressor. So you need to note all those capital letters and small letters. So import XGBoost, from XGBoost import XGB regressor. Okay, and we need to import the metrics module from sklearn. This is useful for evaluating our model. Okay, so from sklearn import metrics. So these are the dependencies we will be needing. So run the cell. As I've told you earlier, you can press shift plus enter to run the cell, or you can press this play button or run button. Okay, so I'm pressing shift plus enter. So this cell has run. So we have have imported all the dependencies. Now we need to import the Boston house price data. So I'll create another text and I'll mention here that I am importing the Boston house price data set. Okay. So we will be importing a dataset from sklearns.datasets. Okay. So I'll create a variable for storing this data. Let's create the variable as house price dataset. So house price dataset is equal to sklearn.datasets dot. So you can see this load Boston data. Okay, so that is the dataset we need. So load Boston. And you need to mention the parenthesis here. So it means we are taking one instance of this dataset. So you can press Shift plus Enter again. So this will load the dataset into this house price dataset variable. Okay, so we can now print and see the data. Print house price dataset. So this is our data. Data. Print.
What's up, guys? In this video, I'm going to
What would have had to have happened in a week for you to look back on that week with pride? Okay, maybe stop breaking promises to yourself. When you say, I'm going to wake up tomorrow at 7 a.m., and when the option comes to hit the snooze button, don't do it. There's one win that you've got for the day. That's action.
The path of the exceptional person is one of an exception, which means that you are not with other people. And rather than fighting that or bemoaning it, see it as an indicator that you're on the right path. Because if everyone else were cheering you on, then it means you're not in the right place, because it means you're just like everyone else, and that's not where you want to be.
When you were born, you are a phenomenon. You are unique. Your DNA has never occurred in the history of the universe, going back billions of years. It will never occur in the future. Your life experience with your parents and everything that you experience in your early years going on up is unique. It's yours. You're one of a kind, right? So that is your source of power. To waste that is just the worst thing you can do in your life. And what the power is finding that uniqueness. What makes you you, and how you can mine that, and how you can go deep into it and use that to create a career path.
So just go and do it, try, learn from it. You'll fail at some things. That's a learning experience that you need so that you can take that on to the next experience. And don't let people who you may respect and who you believe know what they're talking about, don't let them tell you it can't be done. Because often they will tell you it can't be done, and it's just because they don't have the courage to try it.
If you have never had a girlfriend, this is going to be one of the most important videos you've seen in a very long time. For me, it started in junior year of high school. I was sitting in class right at the beginning of the school year. I happened to see this girl across the room that was literally like peak standards in my opinion. When I tell you I didn't find any other girl as attractive as I found this girl, like it was bad. Now for me, junior year of high school had started right after the virus. I can't actually say that on YouTube, but you know the virus. And everyone was wearing masks. Now I was wearing a mask and so was she, so I only really saw from her eyes and above, but just that alone I was like, oh my gosh, this girl is like insane. So what I did, and just out of nowhere, I went up to her and I just started talking to her. I asked her some questions. I can't remember what it was about, but I asked her a question that led her to have to like contact me later. So after I asked a specific question, I ended up getting this girl's snap, and that night we had talked for like the whole night just over text about random stuff that, like, I don't know, it was just like goofing around. So yeah, we're goofing off, and I would say the first like kind of move, teasing her about this girl, so like I definitely don't recommend doing this, but I started teasing her about this girl, or I mean guy, that I knew she had talked to in the past. Now I don't think they had dated, but this guy was kind of known around the school as like being this like douchebag, I guess. And to be honest with you, I was so inexperienced, I had no other way. All I could think to do was like, hey, let me just make fun of this guy she used to talk to. Batting it up, she didn't seem upset. At the point, I think she liked me enough to kind of go with it, because when I was bringing it up, she didn't seem upset. This is all over text on Snapchat. One thing that I've noticed, she's like saying ha 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 ha. For all I know, she could have been completely straight faced. But one thing that I've noticed when you really like someone is like you genuinely find them like way more funny than they might, because you might be with a conscious like guy who had never been talking to a girl before, date them, and even since elementary school, like I was always probably one of the best, going too good to be, well, it actually sent a picture of really ugly, which I thought was really weird, and I only saw the popping it up. It's a great time. She never actually sent a picture of her face, which I thought was really weird, and I only saw the upper half of her face. So I was like, bro, what if this girl is like really ugly below the mask, you know what I mean? So anyway, we're talking, and then I took one of the biggest risks, at least at the time it was one of the biggest risks I felt like I had ever taken. It was really dumb, and I don't recommend it, but that night I was in such a good mood. I was like, bro, I need to like entice this girl or something. So I'm cringing thinking back on this, but I was in my garage, and I didn't have a shirt on because it was, I did that, and I can't remember her response, but I know it was good. I think she saved the snap. Bro, when I tell you, my phone, I threw that thing across. I was shell-shocked, okay? But anyway, we get past this night. I was smiling the whole time. So I would only see her about I would literally try to prepare as much that we shared together. It was only one thing that made it good. Anyway, we can skip ahead of life, but anyway, when I this butterflies happened, however, it was too active. She was, but yeah, it was the night that she was coming over. I think Squid Games had just dropped or something like that. I was like, this is the night that I fell in love. Like, at the time, even though me, that was like this on, it's like video, all that stuff, right? I was thinking about her. Like, we hang out a lot, because if I don't, well, in my opinion. So anyway, we hung out a like over text, 3 or 4, and a girl, in my opinion. So anyway, we hung out a few more times, like probably 3 or 4, and I think it was on the 4th time I asked her, like over text, to be her girl. Obviously, we both wanted that, so eventually towards it, she was like, "Are you gonna ask me?" Or I don't know. Obviously, you want to be my girlfriend or something like that. She said yes, and once again, it was another like euphoria moment. Like, dude, fuck. That like that's a real thing. Some sort of I was potentially where like me a lot of problems. This so the start going down. Everything is a stock just shooting. I mean, was at an all and once it was on stand high. And the reason like throughout my head, whatever you basically create high. And my honest advice to people that are going through something like that, like you guys, like really think, really don't. Even though it's so glamorized and feels like.
House price dataset. So this is our data. So you can see a lot of values here. So these values are stored in the array called as data, and there are another set of values from here. Okay, right? So these are stored in the array called as target. Okay, so this target represents the price of the houses. Okay, so this target means the label of this data set, and this data represents all the other 13 features. So we have seen that crime label, tax and age label, and so on, right? So this data has the values for all those 13 features, and target represents the 14th column, which is the price of the houses. Okay, now we don't want this data as such. Okay, so we want this data to be more structured. So for that purpose, we will be using the pandas data frame. So that is the reason why we imported the pandas library. Okay, so now we need to load all this data into pandas data frame. Okay, so I'll make a comment here. So if you proceed your script with hash, the Python interpreter, so interprets that we are making some comment about the code. Okay, so it is a good practice to include comment this data frame, house space data frame. We need to mention the data which we need to load it. Okay, so we'll be loading this data array to our data frame. Okay, so for that we need to mention this house price dataset dot data. Okay, so pd dot data frame, in the parenthesis I am including house price dataset dot data. Okay, now we need to mention another parameters as columns. Okay, so this columns is nothing but the name of all the features. Okay, so these are the feature names. So you can see in the last line here. So we have these arrays. So we need to include all those feature names in our first row of the data frame. Okay, first of all, let me show you what happens if I run without this column parameter. Okay, so our data frame is created. Now let's print the first 5 rows of our data frame. So print first 5 rows of our data frame. Okay, so for that you can use the function init. So you need to mention this data frame name here. So house price data frame dot yet. This yet function will print the first 5 rows in this data frame. Okay, so there is some indentation here. Okay, as you can see here, we have not included the columns parameter. So what happens is, so we don't have the column names. So we just have the serial numbers as 0, 1, 2, 3. So we don't want that. We want this feature name to be in the first row, right? So for that purpose, we need to mention the column variables. So mention columns is equal to. So we want this feature names arrays to be in the first columns. So mention that here. So house price data set, because this is in the variable called as house price dataset. So hence we are mentioning it here. So house price dataset dot feature names. So this will give the column names for it. So as you can see here, now we have the column names. So the important point to note here is we don't have the price column here because we have just imported this data. We have just imported this data array. We have not imported this target array, which is the price of the houses. Okay, so we need to include or incorporate this price or target array with this data frame, right? So we will do that now. So add the target column to the data frame. So this target is nothing but the house prices. So I'll mention it here, price. Okay, so mention the data frame name, which is house price data frame, house price data frame, and we need to create a column as price. So price column, which is equal to mention the data set here. So this is the data set we have. So we need to mention house price data set dot target to load all this data. Okay, so house price data set dot target. So I'll run this now. Now you can again print the first 5 rows. So as we know that this is the function for that. Okay, so yet function. So I'll copy this here and run it. Now you can see that the target column is also add as price. Okay, so but in the previous case we didn't have that target or price column, so we have included that column as well in this data frame. Okay, so now what we will do is we will check the number of data points we have, so number of rows and columns we have. So checking the number of rows and columns in the data frame. So for that you can use the function shape. So house price data frame dot shape. So this gives the shape as 506 into 14, which means we have 506 rows, which are 506 entries and 14 columns. Okay, so including this price, we have 14 column, right? So now what we will do is we need to check whether our data set has missing values. So if we have some missing values, we need to do some more processing steps before we feed the data to our machine learning algorithm. So we cannot feed data set with missing values directly to our model. So it will make our model not to work properly. So we need to check, is there any missing values? So check for missing values. So mention the data frame dot is null. So this is null function checks how many null values or missing values are there. And if we mention this sum as well, this will count the number of missing values. So this will give the number of missing values in each column. So as you can see here, all represents 0. Okay, which means there are no missing values. So if we have missing values, we need to process the data with methods like dropping or imputation. So luckily in this data set, we have all the data, so we don't need to do any processing. Okay, so in some other projects I'll be telling you how you can handle those missing values. So in this particular scenario we don't have any missing values, so we can continue our step. Okay, now we can get some statistical measures of this data. Statistical measures of the data set. So statistical measures are nothing but the mean, standard deviation, percentage, etc. Okay, so mention the data frame name. So house place data frame dot describe. So this will give the various statistical measures. As you can see here, for each columns we have the count. So count represents the number of data points we have. So totally we have 506 data points, and the mean gives the mean value for this first column, and this is the mean value for second column, standard deviation, minimum value, maximum value, and the percentage. Okay, so percentage means like if 25%, it represents 25% of the value are less than 0.082. Okay, so similarly 50% means 50% of the value are less than 0.256. Okay, so these are some important statistical measures. Okay, so this helps us to understand our data set better. Okay, now we need to do some more data analysis step here. So for that purpose, we need to find the correlation between the data. Okay, so I'll make a text here. Understanding the correlation between various features in the dataset. So let me explain what is meant by this correlation in a minute. So basically there are two types of correlation. They are positive correlation. Basically how these features are correlated with each other. Let's say for example we need to check the correlation for first column, which is crime, and z, which is the zone value. So positive correlation means these two are variables, right? So in the positive correlation, if one variable increases, the second variable also increases. Let's say if crime and zone are directly correlated, if the crime value increases, zone value also increases. Okay, negative correlation, if one value decreases, the another variable also decreases. So that is called as negative correlation. So we need to analyze this correlation value between various features in the dataset. So totally we have 14 features, right, including the price. So let's understand that. So I'll create a variable called as correlation, so you can get the correlation data. data from here. So mention the data frame name here. So house-based data frame.corr. So this will give the correlation data. Now we need to, so this correlation data is stored in this correlation variable. So basically what happens is, so that function analyze all these values and find the correlation between all these features. Okay, so for example, the crime value will be taken and it will be, the correlation of crime is checked with all the other columns. So this is carried out for all the other columns as well. So let's now plot that correlation and understand this. Constructing a heat map. So heat map are very useful for finding this correlation between various columns or features. Okay, so constructing a heat map to understand the correlation. So for this purpose, we need to include plt.figure. Okay, so this plt represents matplotlib.pyplot. So as you can see here, we have imported this matplotlib.pyplot as plt and cbound as sns. So these two functions or these two libraries are very useful for making graphs and plots. Okay, so plt.figure. Now we need to mention the size of our plot. So for that, we need to mention the parameter as fix a heat map for the relation value is equal to true 0.1f t is represented as not. Not. Yeah, that will tell you what this basically does. So c bar is equal to true. Graph with blue color. Okay, so let me run this cell and value. Okay, so this is the heat map. So as you can see here, we have plotted this heat map for this correlation value. Okay, so we have found the correlation from this function data frame.corr for this correlation value. Okay, so we have found the correlation from this function data frame.corr for. Okay, now we have mentioned another parameters as c bar. So this c bar represents the color bar. Color bar is equal to true. So true means we want that color bar in the side. Okay, so this is the color bar as you can see here. So it has various values starting from +1 all the way to negative values to -6, right? Okay, so plus values means positively correlated and negative value means negatively correlated. So I have already explained what is meant by positive correlation and negative correlation. So square, so we want all the values to be mentioned in a square. And fmt means how many float values do you want. So I have mentioned .1f, so it means like I want one value after the decimal point. So you can see here there is one value after each decimal point. So if I give 0.2f, there will be two values after the decimal point. So that's why we are using this fmt parameters. Annotate. So annotate means annotations is equal to 2. So these are, and here values square, and we are the white color. So it represents if LSTAT value increases, the price will decrease. Okay, so basically this LSTAT column represents the lower financial status of people living in that particular area. Okay, so if the financial status of people are low, the price of obviously the price of the houses will be less, right? So that is what is signifies here. And you can see here we have a value of 0.9. So and the color is dark. So it represents this rad column. And we have another column as tax. Okay, so these two columns are positively correlated. So if one value increases, the other value also increases. Okay, so this is how you can find the correlation between various features in a data set through heat map. Okay, so this is very much useful for data science analysis where we need to understand the data more better. Okay, so this is how you can create a heat map. So as we have created the heat map, now we need to split the data into data and labels. So here in this case, the labels are nothing but the price of the data. Okay, so we need to feed this data and label separately to our machine learning algorithm, and through that it can find the pattern between the price and all this data. And this is how it is going to learn from the data. Okay, so now let's separate this data and label. Okay, so create a text as splitting the data and target. So target represents the price or the label in this case. So I'll create two variables as x and y. So in the x, the variable x, let's include all the data, and in y, let's include all the prices. Okay, so let's mention the data frame. So the name of the data frame is house price data frame dot drop. So basically this drop function will drop a particular column. So here I want to drop this price data, this price column. Okay, so I will mention this data frame name here dot drop this price. So this will drop this column. Okay, so x is equal to house price data frame dot drop. Now we need to mention the column name here. So the column name is price, right? So price, and we need to mention the axis as 1. So if you are dropping a column, you need to mention the axis equal to 1. If you are dropping a particular row, you need to mention that the axis is equal to 0. Okay, now we need to store all the labels in the variable y. So what we will do is we will mention the data frame name, so house price data frame, and we need to mention the column price. So this will store the value of the price column in the variable y. Okay, so I'll run this in. Now let's try to print x and y. So I'm printing x and y. As you can see here, now in this data frame, the price column is removed and this price column is stored in another variable y. Okay, now we can do some more processing before we feed the data to our machine learning model. So we have done some analysis on this data. So as we have discussed in our workflow, now we need to split the data into training data and test data. Splitting the data into training data and test data. Okay, so we need to create 4 variables: x train, x test, y train, y test. Okay, so I will be giving this X-train data to my machine learning model. So basically what I'm doing is, so I have this training data and the corresponding label for this training data will be stored in this Y train. And I have this test data. Okay, so this test data will be used to evaluate our model. And the labels for this test data is in this Y test array. Okay, now let's use the function train test split. So you can see in the top that we have imported this train test split function from sklearn.model selection, right? So train test split. So here you can mention the X and Y. So I hope you know that we have split the data into X and Y. So X represents all the data, all the 13 columns, and Y represents the 14th column, which is the price. So we need to mention that here. So I want to split this X and Y into training data and test data. So I cannot do it manually. So for that purpose, we are using the train test split. Okay. So we need to mention the test size. So test size is equal to 0.2. So 0.2 represents I want 20% of the data to be in the test data. So 80% will be the training data and the test data will be 0.2. 0.2 represents 20%. So generally we will be having 10 to 20% of the entire data as test data and 90 or 80% as training data. Here I'm taking the test data as 20%. Now we need to mention the random state. Random state is equal to 0.2. Sorry, 2. So you can represent any number as 2 or 3. So each value represents one kind of splitting. So what is the significance of this is, so if you use the same value 2 while you are doing this programming, your data will be split in the same way my data is splitting. So if you are using the value as 1, your value will be, your data set will be split in a different way. So if you want to reproduce the code, if you want to, reproduce how this splitting is done in the same way, you need to mention the same random state value. Okay. Now I have this X train X test, Y train Y test. So what happens is, so 80% of the value will be stored as training data, and this 80% labels the value for 80% of this data. So the labels of this data will be stored in Y train, and the 20% data will be stored in X test, and the corresponding labels will be stored in this Y test. So it can be done with the function train test split. So we need to mention the X and Y. So we have split the X and Y here, so as data and price. So I'm mentioning X and Y here, and I'm mentioning the test size as 20% and the random set. So you can give any number for random set. Now let's run this. Okay, now let's see how many instances are in X train and X test. So X is the original data. So X train, X test. So let's see how many values are there. X dot shape, X train dot shape, X test dot shape. Okay, X test. So let's see how many values are there. X dot shape, X train dot shape, X test dot shape. Okay, I'll run this. So as you can see here, in the original dataset we had 506 values, so which is the X, and in the X train we have almost 80% of the data, which is 404. And in the X test we have 20% of the data, which is 102. Okay, so this is how you can split the data. And now we need to train our model. So this is model training. So as I have told you earlier, so we are using the XGBoost regressor model. XGBoost regressor. Okay, so this is the model we will be using. So this is a type of decision tree algorithm. So if I want to be more precise, this is a decision tree based ensemble model. So ensemble means we use more than one model. So it's like incorporating two or more models together. So this is an example of that ensemble model. So and it basically it's a type of decision tree model. So I cannot explain detailing about what this model is made of and all the mathematical basis of this model in this video. So as this machine learning course progresses, I will be making separate modules for each of these modules for all the machine learning models. So for example, I'll be making a module for logistic regression and another module. So that module may contain 4 to 5 videos about logistic regression and another module on linear regression, XGBoost regressor, etc. Okay, so in that case, I'll explain about all these models, but I cannot explain all of these in this video. Okay, so the idea behind this video is to add the hands-on training and hands-on knowledge about the project we are solving. So it is somewhat difficult to incorporate all those things because we need to discuss a lot of things when it comes to models. So I'll be making separate video for them. But in this videos, in this project videos, I'll be explaining you how you can use these models for your prediction systems. Okay, so in this case we are using XGBoost regressor as I told you earlier. So now we need to load this model. Loading the model. Okay, so I hope you know we have already imported the XGB regressor model. So we need to use here. So I'll create a variable as model. So let me name the variable as model. So model is equal to XGB regressor. So we have imported already. So mention the parenthesis. So this will load the XGB regressor model to this variable which is named as model. Okay. So to this model we need to fit the training data. Here the training data is X train. This fitting is nothing but the training of the model. Okay. So training the model with X train. So you can do that by mentioning the variable. So I have loaded this XGB regressor into this variable called as model. So model dot fit. So this will train the model. So you need to mention the data and the label. So here the data is X train. So this X train basically contains the 13 features or 13 columns of the training data, and this Y train contains the price value of those corresponding values. So we need to mention both X train and Y train. So I represent it here. So model dot fit X train Y train. So you can run this. So here the model will be trained, and these are the various parameters in which our models are trained. Okay. So now we can evaluate our model on how well it is performing. So this step is called as evaluation. Okay. So in the previous video for classification problems, we have used the accuracy score as the evaluation metric, but we cannot use the accuracy score for regression problems. So basically, what we will do in accuracy score is we will check or count the number of correctly predicted values by the model and the original values, and we will subtract, find difference between both of them. But we cannot do that in the case of regression because all these are numerical values. Okay, so we cannot find
sini rupanya jokes.
Accuracy score for regression problems. Rather, we find the metrics such as R squared error and mean absolute error. So let me show you how you can find those metrics. So before that, we need to do the prediction. So I create a text here named as prediction on training data. So basically our model is trained on this X-train data, and now I'm going to use this model. So this model is now trained, and I'm going to give this X-train array alone, and based on this value, our model should predict the value of Y-train. So once it has predicted it, I will compare the error. I will get the error by comparing the prediction of the model and the original values. Okay. So now let's try to predict the price of the houses with this X-train value. Okay. So we are trying to get the accuracy for prediction on training data. Training data prediction. So for that, you can use the function model.predict. So for learning, for fitting the value with the model, we have used the function fit, right? So for predicting, we will use the function model.predict. So model.predict mention X-train. Okay, so this will, so basically what happens here is the model will predict the price value, okay, the house price value, and store all these prediction to the variable as training data prediction. Okay. Now let me run this. So you can just print and see these values. So these are the values predicted by our model. And Y-train is the original value. So these are the prices of the houses predicted by our model. So these are nothing but in thousands of dollars, like $20,000, $47,000, and like that. Okay. So now we can compare this predicted value with the original value, which are this Y-train. So while comparing this, we can get the error made by the model by comparing how close is the value predicted by the model and the original value. So for that purpose, we'll be using those evaluation metrics. So first we will use the R squared error. So in classification problem, the common metric used for evaluation is accuracy score, and for regression problem, it's R squared error and mean absolute error. Okay, so there are also other errors such as mean squared error and the root mean absolute error and all those things. So in this project, we will discuss about only two errors, which are R squared error and mean absolute error. Okay, so I'll create a variable as score one. I'll get the error value and store it in the score one. Okay, so score one. Now you need to mention metrics. So you can see here while importing our libraries, I have imported sklearn.metrics. So from here we can, this particular module metrics contains the function for R square error, mean absolute square error, etc. Okay, so we will be using those functions. So metrics dot R2 score. So this will give the R squared error for the original values, which is Y-train and training data prediction. So this training data prediction is the value of prices predicted by our model, and this Y-train is the original values. So this will basically give the error made by our model. Okay, so what happens here is, so this matrix, this R2 square function will find the variance between this data, this value and this value from this regression. So based on the variance between both of these values, it will give the R squared value. Okay, now I'll get another error value, which is mean absolute error. So I'll create another variable as score2. Here let's make the function metrics dot mean absolute error. So I want the mean absolute error, and same way we need to mention Y-train and training data accuracy. So this will give the mean absolute error. Okay, so this will just find the difference between the original data and the actual prediction. So it basically subtracts all these values from its corresponding original values, and it will give a mean value. Okay, so this will give the mean absolute error. This is R squared error. Okay, so now let's try to print these values. Print
Mean absolute error. Mean absolute error. Absolute.
not performing. If it is less performing, model is performing really good. Okay, so we can get more accuracy and we get very less error values also if we use more data and other models. So we use XGBoost regressive model because we have a very less very less sized data set. So we only have 506 data points, right? Typically in a machine learning projects we will be having thousands and even lakhs of data. So more the data, more accurate or more well our model performs. So but this is actually a pretty good accuracy score. Okay, so this value is not very much higher. So our model is working well. So you need to note another main thing here. We have made the prediction on the training data, but there is another one more thing that is important. So we need to find the error value for the testing data as well, because the model already seen the value of training data, but it didn't see the value for test data. Okay, so it is just like a student preparing for max exam. Let's say that person is preparing several example questions given in a book. Okay, so those questions become the training data. So in the exam you will be asked to answer several problems that are not in the book. So this will tell how well the student is performing or how well the person is knowledgeable about that particular topic. So those questions that are asked in the exam are called as testing data. So more than the accuracy or error value of this training data prediction is more is important when it comes to test data. Okay, so the test data values are more important than test training data. So I'll also create the error value for testing data as well. Prediction on test data, because for evaluation test data value is more important. Prediction on test data. So we can just copy these things. So we just need to change here as test data accuracy. Okay, so test data prediction. So we have already split the test data as X test, right? So run this cell, accuracy on the prediction for test data. Okay, so let's not. Hello everyone, I'm Siddharthan. I hope everyone is doing fine. Today I'm creating a new play, keras.layers.dense. And so I'll just explain you two more works to do. One is to test our so it should give me a single dimensional array. And hello everyone.
Hey there, how's it going everybody? In this video, we're going to continue learning about Matplotlib and seeing how to create some different types of charts. Specifically, we're going to be looking at bar charts in this video. We're also going to see how to load in data from a CSV instead of just having our data directly within our Python script, because most likely when you're plotting data, the data is going to be coming from another source like a CSV file. Now, I would like to...
You've probably read in the news that deep learning is the secret minimizes, which label the grid while avoiding network to trade. We discussed the learning process of a neural network in the previous module, so
Hi everybody, welcome to a new tutorial series. In this series we are going to learn how to work with PyTorch. PyTorch is one of the most popular machine learning. Welcome guys to this all-in-one PyTorch video. This video takes all parts from my beginner PyTorch playlist and combines it. So let's say we only want one dimension. The last option is to and verify that PyTorch, and yeah, so this equals, this is our iterations for one epoch, because 100 our two division for the, and then we can do the next step by saying loss.back of 10 different classes. So you can change the 120 here and also the 84, but and also let's have a look at some B's. So here we have a B, and yeah, so you must structure your folder like this, and then you can call the data. Recommend that you check out this link. So let's search for @PR, and then we see here we have the method.
This comprehensive course will teach you the foundations of machine learning and deep learning using PyTorch. PyTorch is a machine learning framework written in Python. You'll learn machine learning by writing PyTorch code, so when in doubt, run the provided code and experiment. Your teacher for this course is Daniel Bork. Daniel is...
Experiment tracking, machine learning. All the videos to go with those are available as... That was too good not. So this is very because as we'll see in a second, deep learning is a subset of machine learning. Machine learning is turning things, data, almost any code focused to find the course. So if anything you want, let's say you'd like to write a computer program that's ish and see almost enough these sort of algorithms. I'd rather for literally any purpose, and then programming it to find patterns. Except with a machine learning algorithm, typically we write the algorithm and it finds the patterns, not us. And so literally it could be anything, any input or output from the universe. That's pretty darn cool about machine learning, right? But should you always use number one rule, self-driving car? Realistic bet on it. If you can't rule-based systems, in learning models, 3 or 4, and so can you now with, but not only a banana, what everything that isn't a banana looks like. So insights within large collections of data. Quite powerful, though they are still traditional machine data, which doesn't data to have, or transformers have taken over the past couple of years, and of course, many more. And the beautiful thing about deep learning and neural networks is there's almost as many problems that it can be stand if you've had into these other styles of things here. And again, part art, part science of machine learning and deep learning is depending on how you represent your problem, depending on what bedazzled you are. But for the sake of this course, I might have good tweak or a principle of mind what it learns, PyTorch code later on, but the data goes into the input layer. And in this case, the number of users you can have one, you can use straight. It's using common types of learning in machine learning and deep learning. However, this style of code, though, can be adapted across that agent. So say, for example, you wanted to teach your dog to urinate all over your cat. Pretty good too. Well, that's powered by deep learning as well. Japanese, computer vision could be used. And then finally, natural language processing. Have you noticed as well, your body is powered by what I've learned. Thank you so much. When foundations, well, deploy your PyTorch model. Application/cloud will be depending on what sort of application/cloud that you're using. But generally, it will run some kind of PyTorch model. And it was originally designed and used in-house by Facebook/Meta. I'm pretty sure Facebook have renamed themselves Meta now. But it is now open source and used by companies such as Tesla, Microsoft, and OpenAI. And when I say it is the most popular deep learning research framework, don't take my word for it. Let's have a look at paperswithcode.com/trends. If you're not sure what Papers with Code is, it is a website that tracks the latest and greatest machine learning papers and whether or not they have code. So we have some other languages here, other deep learning frameworks. PyTorch, TensorFlow, JAX is another one, MXNet, PaddlePaddle, the original Torch. So PyTorch is an evolution of Torch written in Python, CAV2, MindSpore. But if we look at this, when is this? Last date is December 2021. We have, this is going to move every time I move it. But if we look at PaddlePaddle code, so we have, if you're not sure what Papers with Code is, it is a website that tracks the latest and greatest machine learning papers and whether or not they have code. So we have some other languages in this fundamental of all zeros, one of our tensors using in the last video we covered. Welcome back. In the last video we checked out, let's now get on to the first step of our PyTorch workflow, and that is, welcome back. In the last video we covered some of, so welcome back. In the last video, with Torch inference mode, we turn on inference mode whenever we, welcome back. And we're going to see a logit in a second. Welcome back. Welcome back. Hello and welcome back. Welcome back. In the last video, we're getting hello, and welcome. Wonderful. So do you see how much I use randomness here to in the last video, we checked our model by doing a forward pass. In the last video, we did the, so start from way back up here, import the image via Torch Vision IO read image, format it,
In this lecture titled Visualization Typology, we're going to look at various ways by which visualizations can be classified. Typically, these visualizations can be classified based on forms, which is what mostly you would come to know that visualizations can be like bar graphs or charts, a bubble diagram, scatter plot, and so on and so forth. Right? This is what most of us are familiar with. That's one way of thinking about visualizations, mostly the formal qualities of the visualization. The second classification is based on the intention. Right? What do you want to do with your visualization? Is it to communicate? Is it to persuade? Is it to discover? Depending on that, or is it to instruct somebody to do something? Depending on what you want to do, you can also think about your visualization that will lead to that intent, or that lead to fulfilling that intent. The third type of classification is based on the user experience you want to provide to the user. You want to provide an interactive experience, you want to look at a tangible experience where visualization is not just only through the visual senses, but also through an audio sensor, perhaps even touch, sensory, and so on. So these three ways of classifying visualization is very useful to think about how to go about designing visualizations. In the second part of the lecture, I'm going to introduce to you a simple yet powerful framework for designing visualizations. And then I will round off this lecture by talking about the difference between data visualization and infographic. This is sometimes used interchangeably, but experience where visualization is not just only through the visual senses, but also through an audio sensor, perhaps even touch, sensory, and so on. So these three ways of classifying visualization is very useful to think about how to go about designing visualizations. In the second part of the lecture, I'm going to introduce to you a simple yet powerful framework for designing visualizations.
First class, we tried to answer some of these questions. You remember, right? Why do we visualize at all? To convey information through a visual representation in order to, from a very simple map, record, or summary spelling story, right? By which process exercise framework to think about how to go about designing for it, right? So, which is where the frameworks become very useful, right? You know what a design framework is, right? And it's just a process, a model by which you can be assured that there is some kind of a quality is met for your output, okay? So that certain things are taken care of, you don't miss out some critical steps and so on. The MD students during their P1 presentation talked about one such model, right? Many students use this divergence, convergence, the double diamond model. You might have also heard about it, right? In the design process, where you converge, where you generate a lot of ideas, and at some point of time you diverge first and then converge, and then again diverge again, and then reach the final solution. One of the most common design framework or a model that is available to you is the cyclical model, right? Which is you design, prototype, test, and then go back to op, right? It's a process tool. Think of when somebody talks about a framework or a model, it is not cast in stone, it is not is proven to be correct all the time, but it works most of the time for certain kinds of situations, okay? Some with better models, which is think of the user, and that would also system that satisfies the system. You just one framework and then say that no, anything that you design, any visualization that you design has to be like this. It is up to you to pick and choose the model that works for you the best, okay? I also tell you what kinds of models work best in what kinds of situations, what kind of problems, right? So in that sense, this is the process lecture, right? So if there is some kind of a way by which I can do visualization so that I will be assured of certain minimum quality in my outcomes, you have to follow one of these processes. And when you get better at doing more of them, you will also develop your own insights, your own practice into how things work, and then you might want to tweak on existing models, or you might even come up with an entirely new model yourself, okay, that works for you, okay? What you did yesterday was a model or a framework free exercise, okay? And that was intentionally given to you just to see how you think about it, okay? Many of you came up with this Murray diagram, right? Which is something that is a standard way of representing timetables in visualization. You might not be aware of that, but it's one of the most economical ways of doing it, right? And some of you asked some very pertinent questions also, right? I think Shweta asked, this is about the users who are passengers, but will this be too complicated for them to understand, right? Some of you ask questions such as, is this representation that should accommodate more trains, more timetables into it, or is it just this only 2 trains that we have to? So when you think about something that represents only 2 trains versus something that can accommodate 10 more trains into the same representation, the way that you think about the solution is also different, right? Okay, so now we can divide or classify visualization based on several factors, right? Now, one of the ways by which we can classify is based on the form, okay? The formal qualities of the visualization. How does it look, right? What shape it has. Okay, so temporal data visualization track time series data, the performance of an indicator over a period of time. They are normally feature lines that either stand alone or overlap with each other with start and a finish line, right? So any kind of temporal data has a very linear form to it, right? You can imagine that. In fact, yesterday you worked with the temporal data, right? At least one variable of your data set was temporal in nature, right? Start time, end time, so it's always linear, right? It always moves in one direction, and you cannot rearrange them at all. So line graphs, bar charts, Gantt chart. So some of you did what kind of appeared like a Gantt chart, right? Which is like this. And I also saw in your P1 presentation, many of you will also include a Gantt chart in your P1, in your P2 projects as well about how you plan to work on your project, right? You know, in the first week I'll do research, second week I'll do this, third week I'll do this, fourth week I'll do prototype, fifth week I'll do testing, etc., right? Time series sequences, timelines, line graphs. So these are all the forms this temporal data takes. Okay? In fact, the data kind of dictates the form that it will assume eventually. So sometimes it could be even spiral in nature, right? If you saw yesterday Nightingale's visualization of a 12-month cyclical data, right? And she had put it as 12 segments, and then it was going around like this. You can fold multiple years also in the same circle, right? For example, it could go one circle and then go another circle, another circle, another circle, and so on, right? I saw one interesting visualization of the polar ice caps and how much area that it used to cover several years ago, several decades ago, and how it has been reducing, right? You know, that's one of the major, most visible part of what is happening with global warming, right? So the caps are melting, the size of the Antarctica and Arctic landmass is reducing, or the ice mass is reducing dramatically, right? So there's a very interesting visualization. You can just look at, or just Google this term, death spiral, okay, plus polar ice caps or something like that. You'll come across this visualization, where with real data they have measured the area that ice used to be covered, and how progressively over the last 100 years it has become smaller and smaller. And there is a kind of a spiral that you can see in the data. Okay, so they have marked it. So every monthly data is available over many years. And if you look at it, you know, it's kind of a death spiral, really, right? So and it semantically also it's very meaningful, right? So from what used to be such a big landmass, now it's become such a small landmass, right? And there is also projections on how small it will get eventually, right? In another 50 years, it will be even smaller than that. In another 100 years, it will probably completely disappear, right? So the message comes across visually very clearly. Okay, then there is hierarchical data. Visualizations are visualization order groups within larger groups. They are best suited if you are looking to display clusters of information, especially if they flow from a single point of origin. Okay, so a classic example of hierarchical data is the tree diagram, right? You know, you start with the stem and then branches and further branches and further branches and so on. Okay? Ring charts, which are variations of that, where the center is in the, where the origin is in the center, instead of at the top or bottom. So it kind of radiates from the center. So you have one single origin, then which branches to maybe 4 or 5, which further branches to 12 or 15 and so on. And sunburst and ring diagrams are kind of very similar in nature. Okay, so what you see is a tree diagram here, which traces back the origins of the SARS virus, COVID-2 virus, which which is somewhere here. We discovered it, early 2000, somewhere 2019 or so, and the possible origins of how it separated from the main branch. Life physical locations, and over classification more examples of this form-based classes, also called as this link. And the last class overlaying location that we center. So where stem and then there's you can fold multiple visualizations several decades ago, and so melting, you can just polar ice use, and there is a kind of a spiral. If you look at smaller single each chart or from here COVID data connection between data sets, clouds which show say okay, so expertise, right? And then you might be able to customize those charts a little bit by what type of data it is. Visual approach on this. There's a most standard approach, whether something and so on, right? So, right, you want to show the least populous state, what is the most populous, or most literate state versus least literate state. So here, most populous state versus least populous state, what is the most populous or most literate state versus least literate state. So here, most of this you want to show and relation is. Then you can also classify based on what is the experience that you want to give to the user, right? So you can choose a narrative through that experience, right? So most of New York Times journalistic pieces are narratives, right? They tell you a story. Okay, so they will tell you a story of how SARS say spreads. Okay, so they will use real data behind it, but they will put characters. Narratives have characters, right? So this person goes to this crowded room, for example, and there are 15 other people, and he infects 2 other people, and then it kind of spreads like that. They want to explain a scientific phenomenon. So the city, them in family. What really instruction? The first explore it. You're not explaining. Okay, interactive ways to compare and contrast. And the neurons visualization that we have done recently, or maybe new data measure of the brain, arrive at some kind of proportional to measurement of the neuron in a specimen, right? And concentration of neurons, the neurons then a few years that take one and so it's up to them to pick part of the brain useful tool for them. So that's a way categorically say that some level of expert simulatives allow the user to experience the intent. An example that I saw came out in writers. Okay, the parameters are like so these are simulate. Okay, so there is a very interesting book which if you're more into the research of it, this is a book that I would recommend, Information Design Research and Practice. And there is a chapter if you're interested.
So this was proposed by a guy called Scott Berinato in 2016 in the Harvard Business Review. Eventually, he went on to write a book about it. But the idea is very simple, right? There are only 4 types of visualizations according to them, and they fall in this spectrum. Okay, they're either declarative, exploratory, data-driven, or conceptual, right? So the 4 types are these 4 types. Either they are used for illustrating an idea, it is to confirm visually something, it is to discover something visually, or it is to generate an idea. Okay, so on the left side, you can notice that they are more conceptual in nature. Sometimes it can be entirely free of data also. Okay, it will become more obvious as I go through some examples. And the 2 types that is on the right hand side, which is about visual confirmation, visual discovery, are data driven. Okay, they are data heavy, and they can be declarative, meaning that you're just summarizing, you're explaining, you're just stating what is there. And at the bottom is exploratory, where you do not know what it is, right? And the exploratory process is supposed to reveal what the explanation is, or what the causes are, and so on. Okay, just keep this in mind, and then as we go through some examples, it will become more clear. Okay, so the idea generation, which is in the top left corner, it is to clarify complex ideas by drawing on our ability to understand directions. Say, for example, up, down, forward, backward is a standard convention that we use, right? Many of you used it in, many of you intuitively used it in yesterday's exercise, right? You started the metaphors and so on. So design conventions, information type is usually processed as basic. Now, a good example of that is what happened 2 years ago when people tried to explain the idea of flattening the curve, right? Now you notice that the conventions that they've used, or the visual elements that they've used, are pretty much borrowed heavily from data visualization, right? So it has x-axis, it has a y-axis, it has 2 curves, and in a very short time. It is it's never going to happen. This lockdown is not going to work at all, right? You can't keep this. But then this illustration was very powerful because it said that, okay, so this is time since first case, daily number of cases. They said that if we don't lock down, this is where we are going to end up, right? This is our current capacity, okay? Or you to communicate. You might have heard about. Another common thing is this foot pyramid. You all know. Brainstorming sessions, strategy sessions, LR working session like that, right? For us it is very common. We do this quite intuitively. This is part of our training. As them are about a strategy session, you can imagine something else, which is like that. They want to score customers. They have now most of their customers are less desirable customers. Okay, right? You can see customers. Then having the economists one, so they start poke visual language design should come products when you design. Okay, the third and the fourth are where most of this interesting visualization happen, right? You're answering 1 or 2 questions with this kind of a project. Is what I suspect actually true? Often mistake it and using it as a true, right? So today's exercise sites that can't be gleaned any other. And map on the IT Bombay website, and usually this is one of the Mandar Rane along with some of his students. Probably it was one of the student projects that actually became this map, I think. One of the CD students in MDes. Now, this is what is called an infographic, okay? And because there is a very heavy editorial hand behind it, okay? You can see that because, see, first of all, the choice of the view, right? A particular vantage point from which the campus is viewed, okay, is a very conscious selection, right? Now, you might be familiar with this plan maps, right, which is directly an aerial view of the campus, which does not have this perspective, right? So the choice of going with one map, one view as to the opposite view is a very conscious design one, right? So why do you think they chose this particular vantage point, as well as the kind of this perspective look or a bird's eye view to this rather than a totally plan or aerial view? Because of the terrain. So, I mean, the choice of the aesthetic style of the map is clearly very illustrative in nature, colorful. You can see that even the plans are all rendered, right? You see all the plans are rendered. You can see the mountain as realistically as it can be. It's a bit abstract, but still it is kind of realistic, right? And you have the lake, not just the lake, but also all the the water plants that are covering most of the lake and so on, right? So, I think one of the things is that many people will approach and they kind of orient and imagine the campus from this view, right? Incidentally, this also happens to be the north, and therefore that's how conventionally maps are depicted. But then, even if this was not north, this would have been the best way to present them, okay? So, the correct way to conventionally represent any map is to present facing north like this. If you have a north, then you have to kind of highlight this specifically to let people know that this is actually not north, but some other direction is north, right? But in this case, it was a good coincidence that both are same. But even if it was not, like I said, this would have been the best thing because this is how people imagine the campus. So even long-time residents will think of a campus originating from here, okay? This is the entry point. And then there are sections which become immediately obvious, and there are some landmarks that are recognizable in this map, right? So people can relate to it. And there are main thoroughfares, right? These major pathways are quite obvious, and therefore, they'll be able to relate to it. But so going for a little bit of realism, top view, purely a plan would be more technical in nature, right? And therefore, a little harder to relate to. Perspective view is a little bit easier to understand. Okay, so that was a choice. But it is heavily curated, right? Right down to the details. You notice that not every building. And this is a map that is frozen in time, right? It kind of depicts the campus at one point of time, and it doesn't allow for additions to it, right? So, for example, 10 years down the line, if more buildings are being added, you cannot automatically update this map, right? You have to go back and start with the very basics and see if the old design still can accommodate these additional buildings or not, right? So, it probably will require rethinking of the design itself, right? So, it's not very flexible to accommodate changes, okay, or addition of new information. So, it's kind of very fixed, very specific, very editorial in nature, and highly curated, okay? And it has got a lot of artistic treatment, right? Aesthetic treatment to it, which are very specific to it. So this is the same campus as seen through the OSM, okay, OpenStreetMap. Okay, OpenStreetMap, if you guys don't know, this is an open source and crowdsourced map where the data is populated by enthusiasts who mark the geolocations of amenities, facilities, pathways, buildings, etc., etc. And there is a bunch of volunteers who make sure that this information is kind of very similar to like a Wikipedia, and therefore the quality of information that is present is not uniformly dense, such as a Google map, for example, right, which is a commercial map. For us as consumers, it is free to us, but if businesses were to use licenses from Google Maps, it's extremely expensive for them to use it. Okay, and you can't even imagine the price that some of these companies pay to Google to use their maps as part of their application. So this is OpenStreetMap, and as you can see that it has many of the buildings, but not all of the buildings. Okay, that's because nobody has actually put them there, and you could be the person who can do that. Okay, you can notice that there are some of the data points are extremely detailed. For example, it marks every single security location. Okay, it also has every outdoor benches that are marked. Every dustbin is there. Every water cooler is marked here, but not every building. Okay, the reason is because over the last few years, students of this course have added more and more data points in this, because I also have this as an assignment for the MD students. So if you go there to OpenStreetMaps, look up IIT Bombay campus, and then you look at any of these things, you will notice that who added these data points, when it was added, and who vetted that and approved it, etc. All that the full history of that particular thing will be there. So somebody added all the amenities also, such as coffee shops, printing shops, Xerox shops, and so on. And this minimum, right? You can everything is controlled in the graphic itself. If lots of original illustrations are elaborate images created to explain information. Right? Quantity of data represented. Typically, data visualizations have more and different kinds of data from infographics. Also, the data in data visualization change frequently and to indicate changes in status. In addition, infographic is less likely to include interactive numbers. So, data visualization can accommodate more. It is it can display more data. So data visualization can accommodate more. In addition, infographic is less likely to include interactive numbers. So data visualization can accommodate more. It is it can display more data. It is flexible to changes in editing and so on. So for example, in this one, right, map, the security stations that are in the campus are all marked by this not so very interesting icon, right, which is like the guy wearing like a police guy icon is there, right. That's because that's the standard icon that OSM uses for that kind of an amenity, right. That's a tag that you have to use, and automatically it will put that in the geolocation. But somebody can just edit it. This entire map can reflect that, right. So all you need to do is change one icon, and then the whole look of it will change. The way buildings are represented, some of these other amenities are can be all edited, and it can reflect in the entire map. Okay, degree of aesthetic treatment applied. This criteria refers to the artfulness of the graphic. A lot of design work has gone into displaying a solution to it be, and the infographics are a representation that is manually drawn. Okay, it's very manually drawn, and therefore custom treatment of information specific to the data in hand, and therefore non-trivial to recreate it with different data. Okay, so the map of IIT Bombay that you saw is very specific to the campus that we have. Again, it will not work for a different campus such as Madras, IIT Madras, for example, right. You cannot apply the same treatment because the geography will be different, the orientation will be different, the types of buildings may be different, and so on and so forth, right. It is very specific to this. Now, OSM map on the other hand doesn't matter, right. The same treatment can be applied to any campus, algorithmically drawn with a different, mostly because the tools are difficult to use, right. They're getting progressively more and more easier to it. The thing is, because everything has to be built from scratch, the code, you have a lot more flexibility. It is relatively data rich. Large volumes of data are welcome and viable in contrast to infographics. Okay. So this is infographic, okay, of this Burning Man festival that you might have heard about. This takes place in the deserts of Nevada, in a place called I don't know where it is. Okay, so I think this is the geographical map of the place of the desert, and so it documents and then presents how the festival has evolved starting from 1986 all the way to 2010. Okay, so this was done around the 2011-12 period, so it kind of stops there. So if you know about the festival, what they do is it's a music festival where they build a huge wooden structure called the Burning Man, and then they burn it on the last day. You can also see how the structures have increased over time. They've gotten bigger and bigger. The attendance have increased. The number of participants have increased. They also hold it in a specific time of the month when it is either a full moon or a half moon or something like that. They also have elaborate entrances that are thematically different every year, and so on and so forth. There are a lot of data related to it, like demographics of the participant, like they are roughly about half of them male, half of them female, which age group they belong to, whether they're college graduates or not, what are the income levels, and so on. Okay, so it's a very specific set of data and it's a very specific response to presenting it, right. You can look at it from everything, right, the color scheme, the predominantly grayscale imagery except for the title, and then what they choose to compare and contrast. Everything is kind of extremely controlled here. The interesting thing for us to note here is the relative sizes of the crowds that attend the festival. So this is the Woodstock, the Burning Man festival attendance. About
In this lecture on geovisualization, Rasagya Sharma is going to talk us through some of the key concepts in geographic visualizations. It's these
lecture on geovisualization
examples.
Cool. With that, let's get started. So I'm going to do a very short sort of lecture on geovisualization. My focus will be on talking through different types of geovisualization with the broad goal that I want everyone in this class to feel familiar with the different terms, the different types, even if we may not actually make all of these today, right? So we may not actually do hands-on geovis work today, but I want everyone to at least build a shared vocabulary and understand when to use which technique or learn to recognize these techniques, right? So usually when I talk about maps and geovis, I generally get asked two questions. The first is, I have this data set, what can I do with it, right? So this is the first thing that we'll try to learn, which is different types of geovis techniques. And the second that we'll try and do is, how can I visualize it well? So some tips on doing a particular technique and doing it well, some tips on choosing which technique to use. So those things will be again something that we'll try to focus on today. We'll run through 10 things, and an hour is usually like not enough, so I will be skimming through. Some of the first few are, I think, the more interesting bits. The ones later on become not as commonly used, so there'll be visual stimulus onto you. Bear yourself after lunch. I hope you don't fall asleep. But let's get started, right? The first thing, geovis. Geovis really means geo, which is maps, and visualization. So what we're really talking about is maps and visualization. But to come to maps itself, I think I did not jump into the history of cartography and maps in general, and even today we won't go too deep into it, but I just wanted to pay at least a sort of nod to the rich history of map making, right? So ever since humans started to make sense of their world, they've always wanted to articulate and share what they understood the world looked like. And you could see that from like ancient folks trying to make really obscure maps of the fact that the world is flat and then there is water that falls and don't go too far away or you'll fall off into abyss, or more mythological and religious connotation where people would talk about layers and you're in this one layer and there is hell below and heaven above, or whichever different religion you're in, right? And so at all of those times, people were communicating this in different forms. What we can see here is on the left, one of the earlier sort of maps that I think comes very close to the real map making, right? So in this case, it's a stone piece on which things have been carved, and the one below is basically a same rendition of it on a sort of white background, right? So you can see it has some sort of a T sort of a shape made. You can see like an eye-like shape made. It has a bunch of circles and shapes drawn, and it was a mix of the real physical reality around them and then abstract religious mythological things. So this is like a Babylonian map back in 600 BC, and they came very close to depicting the real world around them, and this is like 2,600 years back, so fairly like old. What you see after this, which is also somewhere around that time, was the Anaximander's map, right? And this map is probably one of the first maps that was devoid of anything that did not realistically exist, right? So it shows the Earth to be like a disk, and there is ocean all on the edge, and then this is basically like Greek and Roman, so in the center of Europe around Italy, so you can start to see that being the center of the map. And then they did know that there is this area which is somewhat whatever we would call today as Europe, some area below which is what we would call as Libya, Egypt, those areas, and then an area around Asia, right? So we can start to see some maps. Obviously it wasn't colored, this is a digitized rendition, but you can see people getting fairly good at least the sea, the Mediterranean Sea, the Black Sea, those boundaries, the idea of making all of these spaces, right? However, these are still fairly simplified. They weren't very detailed, and they definitely were not very accurate, right? And there wasn't a very good way to know if this is very accurate or not, till you have people like Leonardo da Vinci, who pretty much made the first real-ish map that we can see, which is top down. So up till now, like even before 1500, a lot of people were making detailed map of cities, but the approach to make it was go find a cliff that is the nearest, on top of the cliff stand, and then you get this perspective view of the city, right? And they would make that as a map. So a lot of map before 1500, in fact even around 1500, you'll find are always from a perspective. Leonardo da Vinci's map was probably the first map which is a top-down view, as if it is being seen by a satellite. However, 500 years before a satellite was invented, and his approach to do this, I think he was commissioned by this newly formed prince who became like a king in Imola, and he wanted like a view of his sort of town or new estate that he now has. And this basically has a bunch of roads that you can see, and very heavily packed like residential area. And Leonardo da Vinci said to have made like an interesting instrument to measure distances, and he made like this round sort of disc, which led to like, okay, one sort of revolve the disc one time all the way, and then that circumference becomes some X amount of distance, right? And he basically rolled that disc around the whole area to measure and actually get an accurate sort of measurement of this area, and then you can see some sort of context being built around the center. So this, I think, is one of the sort of birth of interesting, accurate map making, because before this there was always dragons and mythical things on maps, and you'll see these nice, interesting religious elements, etc., mixed with the real world map making. So this was maps, and I've obviously not done justice with a single slide, but I'm hoping you at least get some sort of references on it. By 1800s, maps have become commonplace. Everybody has really accurate maps. People have found out ways to use maps for traveling, which basically led to the whole sort of golden age for at least Europeans, where they went and found a bunch of different countries, found out the world is not flat, and all the other interesting things. But you can still see some very interesting use of map now being used to convey other layers of information. So now maps are becoming an sort of background or context, and more data is being visualized on top of maps. So 1850s, this is the whale chart on your left. It's a very interesting piece because it's one of those crowdsourced maps which people don't expect were happening in 1850. So this one person, I think the sergeant, he basically would sign up fishermen who would go hunt for whales by telling them, here is a diary. When you get to the place where you find a whale, make sure you record what type of whale it was and what location you were in. And then come back and give me that diary. And in return, I will give you a map that has every other sailor's recordings of whales as well. So this is very interesting collaborative exchange, right? It's not like paying them to go find where whales are. They're anyway doing this, but they have a win-win because they get to know where every other fisherman is also finding whales, right? So they build this map collaboratively, and you can see he basically divided that whole Pacific Ocean side with a grid, and this is a particular projection that we'll talk about in a bit. And then within each grid, there is cells that are colored either pink, blue, or green, depending on the kind of whale that was available there. So this is interesting because the map is no longer the important piece here. It's just a context to understand where to go. And you can see another one. This is a map of India, Hindustan back in 1822, and all the sort of princely states and different sort of Raj kingdoms that were there in 1822 back then. And this has obviously been done by a sort of British, I think, cartographer who was asked to make like a map of how India looked like back then. Right? So you can again see that the world or the map is a layer, and then on top of it now there's a layer of like which estates or which sort of people live where. And it's interesting because the one on the left is about naturally existing things, right? So it's a very focused on nature and like things that are available in reality. The one on the right, in some way, is conceptual, imaginary. Like if you go from the sky, there is no boundary between these two princely states, but these are just humans who form like perspective of okay, this is my kingdom, this is your kingdom, etc. But for us as designers who are building maps, it's good to understand what maps represent. Right? So maps by themselves would represent a bunch of things. They would have either things that are naturally available, area, that's water, land, terrain types, or things that humans have come to agreement that this is how it is, like country borders, or things that humans have built, like land use, buildings, transport networks, points of interest, etc. Right? Usually, you would store this map data in two forms. So you would either have something that's called raster or something that is called vector. Now this is probably the only slide that gets fairly technical. Map data or things that humans have built, like land use, buildings, transport networks, points of interest, etc. Right? Usually, you would store this map data in two forms. So you would either have something that's called raster or something that is called vector. Now this is probably you would like country borders or things that humans have built, like land use, buildings, transport networks, points of interest, etc. Right? Usually, you would store this map data in two forms. So you would either have something that's called raster or something that is called vector. Now this is probably the only slide that gets fairly technical, so it's okay if you're not able to follow along too much. However, I'll give you some very quick works, points of interest, etc. Right? Usually, you would store this map data in two forms. So you would either have something that's called raster or something that is called vector. Have come to agreement that this is how it is, like country borders or things that humans have built, like land use, buildings, transport networks, points of interest, etc. Right? Usually, you would store this map data in two forms. So you would either have something that's called raster or something that is called vector. Now this is probably the it is like country borders or things that humans have built, like land use, buildings, transport networks, points of interest, etc. Right? Usually, you would store this map data in two forms. So you would either have something that's called raster or something that is called vector. Now this is probably the only slide that gets fairly technical, so it's okay if you're not able to follow along too much. However, I'll give you some very quick tips to understand the two. A raster is like an image, like my photo that you would take from your phone. Every pixel holds some information. For a typical photograph, your raster image is holding RGB, red, green, blue, basically color of each pixel, and then it comes together to form like an image. Similarly, for a particular kind of holding RGB, red, green, blue, basically color of each pixel, and then it comes together to form like an image. Similarly, for a particular kind of satellite imagery, you may swap the RGB value with some other value. That would be something like elevation. So every pixel is basically an elevation, and you can get like a map of just elevation as numbers, and you could color it to then get like a feel of this area has peaks, this does not. Or you could get temperature or any other aspect, right? So this is one approach which you generally use for things that are maybe recorded from satellite imagery. They're very imagery based, so they're using some device to look at the world and then give you back information. Whereas the other set is vector, which is usually made either by hand or by tracing or by using some mix of machine learning that we do today with some sort of human intervention. And in this case, you would either make a point, so a bunch of things, then you would put point, 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 these are these things, or you would make lines, like this road goes from here to here, or you would make polygons to say this is one building area, this is one park area, this is one national park, this is one hospital, etc. The advantage of a vector is that just like an illustration or a drawing, for you, a vector becomes something that can be zoomed in as much, right? So you have all the level of detail. It also gets saved in a very different way, unlike an image. So you can actually give a lot more properties. For example, a road can have a property of the name of the road, how many lanes does it have, what kind of road is it, is it a big highway, small road, does it have a one-way, or does it allow traffic both ways? All of those properties can come on a single line. Right? You can't do that with raster, which is just images. And so you'll find a lot of data today which you visualize often being in the vector form. However, some layers of maps may be available in a raster form. Generally for raster, you will find these formats, GeoTIFF, JPG 2000, these are like formats that you can import into your mapping platform. Whereas for vectors, you have things like shapefile for data sets that are slightly older or are used for government purposes or for journalism. These are common, slightly more, I won't say archaic, but more traditional formats. Whereas newer formats, especially built for web, are JSON formats like GeoJSON, TopoJSON, or a CSV, which is comma separated values. And then there's also KML, which is something that Google prefers. All of these are just format names. You don't have to remember them. We won't need them anytime today. But if any of you try to visualize data, these might be things that you may come across. Right? Just familiarizing yourself with this. So maybe a few weeks later, you're making a map with some data on it, and like, Rasagya told me about KML. You don't have to get scared about it. And this is like a typical vector data set, right? So you have a map. On the map, there is one dot, which you can see over here, right? So this one is India Gate. So I could represent that as a node or a dot. I could make a line, which is a way. So this is the road, like the Rajghat sort of a road. And then I could make a sort of relation or a polygon, which shows a building. Like this is this sort of in front of the president's house. There are a bunch of administrative buildings, and you can see those marked out on a particular map. Right? So this data set would essentially have 1 point, 1 line, 1 polygon, and that becomes a data set that we can then import onto a map like this of Delhi. Now, we touched about this very briefly yesterday, but I also want to again sort of highlight some of this, which is that maps are turning something that is real, which is a globe, kind of like a sphere, but not really a sphere, into something that is 2D, right? And therefore, there is always distortion. You'll have to skew things around, and projections are basically equations that allow us to do this. So there are a bunch of different projections, a bunch of different ways to take a globe and then turn them into a 2D surface. You can see some of these here. This is from Bostock's one demo of different projections, and he cycles through a bunch of variations. You obviously can see the most common projection, which is called Mercator. One of the advantages of Mercator, it makes latitudes and longitudes perpendicular to each other, so they are very simple grids on a map. They also stretch very interestingly. So anything on the top, like if you make a straight line on a map and you sail in that direction, it would be a straight direction. That isn't always the case if you look at some of the other bits, and some of the other projections get like more and more wild and interesting. And like most things, there is an XKCD comic about it, which says what your favorite map projection says about you. And obviously the first one is Mercator, and it says that you're not really into maps, right? So clearly a judgment here of people who like Mercator. But then there are a bunch of other ones, right? Like this one, which is Andy Grit. I mean, he basically took something like Mercator but made like a nice circle around it. So it feels like it's more like a real. This one, which is Van de Graaff, I mean, he basically took something like Mercator but made like a nice circle around it, so it feels like it's more like a real world. But that's really not how Earth is, and this probably would be a better map if Earth was a disk flying in the air, right? There are a bunch of other interesting XKCD which sort of comic talks about other map projections. So for anybody who wants to nerd out, go check XKCD about this. But for us as designers, it becomes interesting that map making is very similar to any other sort of design, visual communication artifact that you make. There's always figure, and then there is ground, right? There's always a subject, and then there is something in the background. So this is an example of a map that I had done. This is a small experiment for Bombay, and in this case, the map visualizes all bus stops in Bombay that are on OpenStreetMap, and then we had some traffic data aggregated over a month, and it visualizes the major roads where there is like a lot of traffic, right? And you can basically see in this map the sort of arteries like structure of all the roads in Bombay, a bunch of areas where there are a lot of bus stops. So the focus here was to highlight this, the bus stops and the traffic, right? And therefore that is shown in this bright sort of neonish, lit up colors, while the map layer is really subtle. I'm not even sure if people in the back can see it, but it's this sort of grayish dark map, right? And water is shown in black, right? So in this case, we apply the same principles of figure and ground, where we say that something that needs to stand out on a dark surface needs to be lighter. If it was a light surface, it needs to be darker, and we would use the same principles if you're visualizing data, right? So instead of taking a map like this, which is like a typical Google map, fairly colorful, it has roads in different color, it has paths, it has lakes, instead of that, I would recommend we start with something which is minimal, like a light map, right? And in this case, the colors are muted, and so they're all gray. You can't really see roads in this because this TV again has some really nice projection. A recommended way, instead of using a very colorful sort of map which you use to show already things on it, might be easy to take like a map which is minimal in the use of color. It could be light map, it could be a dark map, and the reason is that then this map can work really good as a background, so that you could put data on top of it on the foreground, and that data could then be more visually like evident and stand out. Right? And you could use the basics of Gestalt to say that the map will feel as one entity and the data will feel like one entity instead of it getting confused together, which might have happened if we would have visualized the same sort of circles or something else on top of the previous map. Right? So whenever we're thinking about GeoVis, we want to first start with a base map, which is our context, and then think about the data. What form is the data in? Is a vector, a raster, what we will show onto the visualization as well. Now let's look at some techniques. Right? The first technique is that the map itself has an element that visualizes data in it. Right? This is a fairly tricky and mostly subtle method. You would either see it like this, which is your typical traffic map, right? And this is a map that I made for Delhi. We were trying to figure out if our traffic data is accurate or not. So we got some aggregated data of traffic for Delhi, and then every road is basically shown as a line, but then the traffic level is also shown on the same line. So you start to see a visualization happening on a layer of the map, in this case the road itself, right? And we use color or different hues to show high traffic, low traffic, something that is very obvious to everyone because now we use Google Maps for navigation, right? But something that might not be as evident. And so if you look at Google Maps, you may have noticed that while most of the map is gray to show land, some elements have this yellowish background onto them, right? And what Google Maps does is it tries to highlight areas of interest, or specifically like areas that are popular in a city, by giving it this sort of a shade. This keeps changing, so in different versions of Google Maps you'll see slightly different treatment, but there is always this focus on trying to highlight which part of a city is slightly more popular. And so if you're in a completely new city and you want to at least see where are more interesting shops, places to eat, etc., just using this and nothing else, just the background color of the map, can help you identify that, oh, this is Connaught Place, this is definitely like this central popular area in Delhi. It goes all the way till Janpat, a lot of shopping here, and then there are some other patches here and in the north which also are popular for food, etc. Right? And so suddenly now they're using this element of visualization inside a map to really differentiate between an area that is not popular versus an area that is popular. Right? So this two are examples of just using maps or a layer of a map as visualization. However, this becomes fairly complex to pull off. Right? You need to have access to the layers of map. It's also very subtle. For a lot of people who've seen Google Maps, they may not have noticed that this sort of coloring exists already. So it works when you are making a general purpose map, but you want to maybe bring in some element of traffic or some other information. The obvious next method to visualize data on top of a map is to put dots on a map. Right? And this is one of the most common, easiest to get started with, and has a lot of flexibility as well. This is what it looks like. So you take a base map. In this case, let me take a map of Bangalore. Taking like this nice minimal blue map that I made. And then I throw a bunch of dots on a map, and I'm done with my visualization. Right? So this is all the bus stops.